Okay, so may I start? Okay, so it's time to start the session. Hello everyone, thank you for coming. Welcome to the ICRA 2020 workshop, How Will Autonomous Robots and Systems Influence the Society? I am Minoru Asada from Osaka University, Japan, and I am one of the organizers. And other organizers, Raja, Tax, Phil, and Yush. We have the three sponsors. First one is my own research project, the JST Strategic Basic Research Program and Legal Beings. And the second one is also the same, the JST, and TATS is a PI and the rule of the law in the age of the AI. And the third one is my research center of the Osaka University. The main purpose of this workshop is that, as you know, the AI and the robotics technologies have been empowering the artificial systems and the robots with a certain kind of the autonomy. So it's time to reconsider the meaning of the autonomy in the artificial systems from not only the technological aspect, but also from other more broader perspectives, such as philosophical, the ethical, legal, and the social implications aspect. So to do that, we have collected the 8 speakers, including the main image speakers of the Peter Paul Verbeek. And we'd like to ask the audience, please utilize the Zoom's chat to ask the questions and our comments. We pick them up and ask the speakers to answer during the discussion time. We may not be able to show everything due to the time limit. And also we'd like to ask, please utilize the chat during the discussion time, and we may respond to them and also answer the question or comment after the workshop. Thanks. Okay, now it's time, it's my time. The opening keynote address, autonomy in the machines and the humans. I'd like to show the first one, this video clips, is the Da Vinci Android. So the casting process of the face of the relevant Da Vinci Android. In case of the Android, maybe the Professor Hiroshi Ishiguro of our university is very famous, his Android. But before the Leonardo da Vinci Android, his androids, all the real person existed. But as you know, the Leonardo da Vinci is a person more than 500 years ago. Therefore, we do not have any data. Therefore, we contacted with the people in the Da Vinci Museum in Milan, Italy. So that we decided the age and the shape. The mechanism is the same as the Hiroshi Ishiguro's androids. So pneumatic actuators to control the facial expressions and so on. So due to the limit of the budget, in this case, only the head movement, so the neck movement and the facial expressions and so on. And also this time, this android is teleported. So the teleporter can control the neck movement and also the facial expressions. So it seems to me that there's no autonomy, but in the 5 years ago, we had the exhibition of this android at the Da Vinci Museum. So 5 years ago means the World Expo in Milan. So the teleoperator's movement copied to the android and also pushes the button for the expressions. After pushing the button, the system automatically generates the facial expression. Therefore, even though this android is teleoperated, but some level of autonomy embedded. The second part is that of the RoboCup. I'm one of the fans of the RoboCup. I'd like to show the best video clip of the last year. So the final game of the middle-sized league, the 5 robots versus 5 robots. So the orange color comes from the Netherlands, and the blue team comes from the China. So this is a fully autonomous. So the omnidirectional vision system and the omnidirectional moving, and find the ball, pass the ball, and shoot the ball to the goal, and so on. So this case is a fully autonomous in the sense of the soccer game. So the introduction of my talk is the same as the workshop. So anyhow, so we should reconsider about the autonomy. So autonomy must be better understood. So some example of the definition of the autonomy. The number 1, act according to the given instructions without any thoughts. Number 2, decide to act according to the given instructions without any thought. And number 3, decide to act accounting for the dominance or restrictions from others and reflect one's own idea. So notably, this can appear to be the same as 1 to 4. And number 4, decide to act only one's own idea without accounting for any dominance or restriction from others. So what many people suppose that number 4 is the real some autonomy something. But as you can see that the above is not completely independent of each other. And currently most AI robot systems are categorized into one. And there's a possibility of having autonomy lies in the hand of the designer or programmer. Even though programmers may also experience one with regard to the supervisors. Since the robot in this case does not have any concept of the self as an active agent or clear conviction that it is the module of the decision making, therefore this scenario can be more correctly categorized as less than 1. On the other hand, even for humans, the free will is only the virtual, and it is clear from the neuroscience that our level of consciousness is constantly being adjusted by various internal processes, that's the unconscious process. Thus, it's difficult to insist that only human beings are purely autonomous, as is proposed by in Kanto's moral philosophy, which is discussed later. While the artificial system lacks their own autonomy, clearly the difference between them seems simply relative. In 1970s, the Maturana and the Varela proposed autopoiesis, focusing on the self-creation, including the regeneration and self-boundary decisions. If we apply this idea very strictly, so any artificial system cannot be the autonomous, but it's instead heteronomous one. However, the complete simulation of self-creation developed by the Maturana Varela is an autopoietic system, it's the machines, while also showing the autopoietic nature. So therefore, it seems possible for the machine program to exhibit some autopoietic nature. Furthermore, human beings sometimes show the heteronomous behavior. For example is some people, the manual people, only obeys the manual one. That is the heteronomous. The shifting from the sensory motor system of individuals to the social system level, the autopoietic nature in the strict biological sense is weakened, and that its meaning may be derived as a more essential or machine shared property. The Varela later shared the idea of the Michel Foucault or Maurice Merleau-Ponty. He demonstrated the importance of the interaction and communication and called for the autonomy norms to be updated. Therefore, I suppose that the machine autonomy could be more authentic if the concept of the self, agency, empathy, and ethics are introduced into the design. So here I'd like to touch these the issues. So review the ideological background and the concept of self-agency and the self-consciousness. And to direct that, I'd like to propose the Watson working hypothesis. The pain nervous system is a key component. And through the development of the mirror neuron system, empathic behavior can be learned. And finally, maybe emergence of morality and so on and so on. So this shows some ideological background of the relation between human beings and things. It's not everything, but just some part. On the left side, you can see that the Descartes and Immanuel Kant. These very famous guys, but they focus on the too much human-centered, and they show some very clear boundary between the humans and object. So now object of the AI system, and the AI system is much more intelligent. Therefore, the right-hand side shows some idea of the phenomenological reduction of the Fustal and the Heidegger and the Maurice Merleau-Ponty. They focus on the embodiment. And in the current term, they focus on the human-machine interactions. But also I'd like to mention the Italian philosopher, the Vico. He mentioned that the real understanding is possible by creating something. So his idea is very close to us. So at the beginning, Alex mentioned the self and agency. So I just borrowed the self level from the Neiser's definitions. The Neiser's actually originally he mentioned the 5 levels of the self, and I pick up only the 3. The starting the ecological self, that interaction with the environment. In that case, the body representation is one of the main issues. And the second level is interpersonal self. So interaction with the caregiver, and it's the beginning of the self as an identification. And finally, the social self, it's a perfect one. So I would suppose that starting ecological cell, interpersonal cell, and finally social cell, and maybe some self-consciousness and so on. About the ecological cell, so also the Gallagher mentioned this is a minimal cell. And the minimal cell consists of the two parts. The first one is to match as the Ford comparator provide the sense of the agency for the movement. This is the Ford model. And the second part is the after the actions. So match the feedback comparator provide the sense of the ownership for the movement. So he mentioned that the inner self is composed by the two parts. And then after that, the interpersonal self or the social self would like to have some sort of the self-consciousness of the agent. To do that, I like to propose some working hypothesis. So I like to introduce a pain nervous system, the embedded pain nervous system into the robot to make a robot feel pain. And through the mirror neuron system, the robot may feel pain in others. That as a result, some empathic mind and also the morality emerge, and the robot could be the moral beings and also the subject to the moral consideration, and finally some legal system will be considered. As you can see, the number one, number two is the black, and gradually the light gray, it means my confidence. So the later and the later, the less confident. So this shows that this comes from the textbook, the neuroscience. So the pain has some parallel pain pathways. The first part is a sensor discriminate part. That is where and how much strong and what kind of pain. So I suppose that some sensor discriminate part is embedded already. On the other hand, the second part is affective and motivational part, and the core of the pain or the memory of the pain or something. And we suppose that the second part is some target for the learning after the birth. For the preliminary experiment, we developed some soft tactile sensors. So you can see that this is a very soft touch, okay, and also very, very hard touch. So as you can see that in the signal level, you can discriminate soft touch and hard touch. Okay, so based on these ideas, this shows some, some idea of the early stage of the pain experience. So prepare some mechanoreceptors and the nociceptor and the vision system. So the self as agent, some experience of pain situations and the memory, and also learning to the pain relief behavior its own. Then through the development process of the mirror neuron system, next stage will come. So mirror neuron system, or the mirror neurons, originally found in the monkey's premotor cortex. And this neuron discharges both when executing an action, and also when observing the same action performed by other individuals. The understanding others' action and the intention based on the self-motor representation is very, very useful. But not only actions, but also sensation and perception is possible. The example, the touching side. So we like to apply this idea to the pain sensation too. And then after the self-experience of the pain, the sharing the pain experience like this one. So through the development of the mirror neuron system, so the agent can feel the pain in others and learn through some motor the behavior to the pain relief behavior, and also the hippocampus, so some sort of the memory and so on. So to do that, some evaluation of the empathy is a good idea. This is the Franz de Waal. He has shown the, the evolution of the empathy starting in emotion and empathy, and also in parallel with the physical behavior of the imitation, and also includes the self-other distinctions. So I make this is the upside down, and starting the ecological self, and so the social self. And finally, this is the concept of model of the empathy development. Okay, it's time to summarize. So difference of the autonomy between humans and machines is relative, and self and the agency are essential for the machine autonomy and also self-consciousness. The robot can discriminate between touch and pain, and based on the mirror neuron system, a robot may feel pain in others, and the beginning of the empathy. And pro-morality after sharing pain experience may emerge, and design of motor agents could be possible. Okay, so thank you for your attentions. Okay. Okay, so I stopped, thank you. I stopped my talk. And then, okay, the question and answer is at the discussion time. So with the second talk is my old friend Raja. Raja, are you ready?
I'm ready, thank you. I'm going to share my screen. Okay, can you see my screen?
Yeah, yeah, go ahead.
Okay, so I'm going to argue that it's not grounded, technically speaking, to endow machines with legal personality. And in addition, it's morally flawed. So we shouldn't do that. So that's the end of my talk. Thank you. The argument. Now, let's first try to understand what is a legal personality. This is a concept. Actually, it's an artificial concept. It refers to entities that can be defined within the law system as possessing property, being sued, be part of a contract. So it's a kind of convention for legal issues. And legal issues are very important because they determine how people interact together and how society actually can live in peace, because there is a judicial system and that the activities are defined within a framework, within the framework of the law. Humans have naturally, and we call them natural persons, have naturally a legal personality. This is very profoundly rooted in history, but it appeared over time that a concept of legal persons, different from natural persons, was also useful. And I'm saying useful on purpose, because it's actually a kind of artificial or fictional, these are words that are used in the legal area, to enable things that would be possible but complex in otherwise. And the concept actually of legal persons is to define entities which result from assemblies of humans. For example, corporations, associations, even states, so that these entities act as if they were a person. But these entities actually are shielding persons behind. Further, and actually rather recently, the concept has been extended to include other kinds of entities, and specifically ecosystems. So, for example, in New Zealand, in 2017, a river, the river Te Awa Tupia, has been endowed with legal personality. And the reason behind this decision is to protect the river and to endow it with some kinds of rights so that it's preserved. And one of the reasons behind this also was that a tribe had beliefs about the river, so respecting these beliefs led to define rights for the river. In Ecuador, for example, already in 2008, the idea of an ecosystem that has rights to be preserved, to be maintained, to regenerate, to live, in other words, has been recognized. And again, what you see underlying this is protection, because of course, we cannot define any duties to this ecosystem. But this ecosystem can be destroyed by humans or can be polluted by humans. And therefore, the reason behind these legal provisions are protection. And in Bolivia, you have also similar things. And other places, Brazil, have also come up with this kind of laws. Animals, of course, as Minoru said, the it has been some time already that a frontier has been drawn between human beings and animals, because the common understanding was that animals didn't have sentiency, they didn't have feelings, they didn't feel pain, although we see, and there is scientific evidence behind this, that this is not true. And the law evolved to include this fact. So again, animals, this is a French law, are human beings that are sentient. And again, the reason of this law is protection of those animals. It's very important to keep this in mind in our discussion. So what is the notion of legal personality saying varies among authors, among scholars in law. And this makes things complicated because there's no clear and accepted perception of this. And you go and discuss with someone from the legal domain, you can get several answers. And I presented here a few different understandings. For example, the first understanding, Francesco Carneluti, is defining a legal personality as the meeting point between the economical element and the juridical element. So here it's about contracts, it's about the ability to own property, etc. Friedrich Carl de Savigny is defined it as a person capable of obligations and rights who is endowed with will. Minoru mentioned about will. Again, you can see that there are different things. And for example, Eduardo Garcia Menez, any being capable of having powers and duties as a subject with rights and obligations. So this notion of rights and obligation comes on very often, but it's not actually a part of a complete definition that you can find everywhere. Before Descartes, before Kant, animals could be considered as responsible, liable to actions that they have done. For example, here you have a depiction of a trial in 1467, if I recall well, a trial of a sow and pigs at Laverny. And the trial was about accusing this sow of eating a child. Therefore, it was there was a court, and it appeared in front of the court with its children. You can see the small pigs, and it has been recognized guilty. The children were recognized as not guilty because they were too young, and the sow has been burned alive as a punishment. And the costs of the trial were paid by the owner of the sow. So in the Middle Ages, actually, and there are many other examples like that, animals could be considered as liable. And behind animals, a human being, the owner, if it wasn't a wild animal, of course, can withstand some penalty to do this. What do we do today is we consider that the owner is responsible and liable. And this is a progress from that situation, because what does it mean to burn alive a sow that has done something wrong? This is the question. Now, this text that I'm showing you now raised a lot of controversy. It's not today something that is considered by the European Commission as something that is going to be implemented. Things can evolve, but In 2017, the European Parliament has proposed to look on the problems of liability of autonomous robots. And they considered that there is an issue when, in the scenario where a robot can take autonomous decisions, the traditional rules of liability cannot really be activated because it would be difficult to identify the party responsible for providing compensation. So here, behind this, you have this notion of liability, which is exactly why pigs were on trial in the Middle Ages. We have to identify some entity that can be considered as liable. So you see that from the legal point of view, it's only an artifact, if I may say, because we need to solve a problem. And the problem is to identify a liable entity. And it's complicated to identify human beings, because behind companies, for example, or associations, there are always human beings. But who is behind the machine? Who is behind the pig? And therefore, let's consider that the robot is responsible, is liable, and the pig was liable. This leads to a lot of confusion, because, of course, what can be considered as a practical solution from the point of view of the legal system leads to beliefs and to understandings about robots, which is quite different. Now, let's take, for example, the autonomous car, which is the classical example. And here you have an autonomous car, and someone has crossed the street just in front of the car. The car doesn't have time to brake. What should it do? So you have this classical moral dilemma, or so-called moral dilemma, where the car has to decide for an action. And here you have, for example, 6 possibilities. In each possibility, you have a critical consequence. Someone is going to be hurt. Who decides? If the car decides, then the car is liable. Is this correct? Well, no. What about autonomous weapons? If an autonomous weapon decides to fire, who is liable? Now, we have to get back, and this is why I'm saying that technically, this is not grounded. How do machines make decisions? The machines make decisions following algorithms. For example, here in the Markov decision process, you have the definition of states, of actions. You have a probability distribution to reach a given state from a given action. You have a utility function, and you optimize a function. You are going to optimize the utility function. Who defined the utility function? The designer. Who is computing the utility function, or what is computing the utility function? The machine. Who is liable? Let's take a machine learning process, because of course a lot of people say, well, learning, it's not the same thing. It's not a systematic algorithm. Who is then defining the learning output? Well, learning, and I'm taking here supervised learning, is about providing output values given data and processing this data to extract features, etc. And the main thing that is happening in a training phase is the optimization process that is going to set up the values of the synaptic weights so that you get the desired output. Who has designed the system? Of course, the human beings. And when the system was decided to be dispatched on the market, it's a decision by the human being saying that, well, it works properly, it has an acceptable performance, an acceptable level of accuracy, so we can make it a commercial product. Is this system deciding exactly to recognize that this is a person, or this is a cat, or this is a cyclist, so that the decision-making process from this is going to select the proper entity, if something goes wrong, of course, to hit? There are major differences between humans and robots. And again, Minoru alluded to that, agency. What is agency? Agency means you decide, human beings decide by their own purpose, of their own purpose. We have the moral stance, and this is not something that can be defined just by reading moral theories and deciding to be utilitarian or consequentialist, or deciding to be deontic, or deciding to be virtuous. What does it mean for a machine to be virtuous? And we have also rights and obligations, and this means that we are sensitive to punishment, and we are sensitive to injustice because our rights are not respected. How can this be projected on machines? And there's also another difference between humans and robots. It's appearance. And now this appearance is more and more challenged because, as Minoru shows us, we build a lot of robots that have human appearance. So to conclude, should robots be endowed with legal personality? Now, again, historically, this is specific to human. The reason humans are naturally legal person, it's beyond any discussion, is their capacity to deliberate about moral questions and to act intentionally. And when you can't, for example, when you have cognitive deficiencies, someone else, another human, is identified to be liable, to be responsible of your acts. And this is also the case for small children. Legal personality, as you have seen in what the scholars say, leads to rights and duties, or duties, not always both at the same time. And when they are extended to other entities, it's basically to shield individuals and to make things practical for collective actions. But still, when it comes to make the decisions for example, the penal system, individuals will be at stake. For ecosystems, it's for protection. Again, it's a practical trick, if I may say. So ethical deliberation doesn't exist as an algorithm. It's our moral autonomy, which is related to our agency, that enable us to do this, to act intentionally. Whereas machines, as I showed in my two examples of learning and Markov processes, operate at the computational level, and only on the computational level. They don't know, they don't understand, they are not aware about the reasons underlying their algorithms and therefore their decisions. Thank you. Oops.
It's okay. Finish?
Wonderful.
Yeah, thanks, Roger. That's a very good contrast of the definition of the agency and also something like that. So I appreciate. Okay, anyhow, so Phil, could you prepare for the presentations?
Sure.
Phil?
I'll start sharing my screen.
Okay, thank you. Okay, so Roger, please continue the discussion at the discussion time, right?
Yes.
Good.
Okay, can everybody see my first slide?
Yes, please.
Fantastic, so I'll continue. So hello everybody. Today I'm going to be talking about risk assessing robots, but what about humans? So I'm a psychologist, and I'm going to be talking about the challenges and opportunities in developing safe and secure systems. I'm very much double badged, so you can see Airbus logos on the slides. So I am seconded to Airbus as a technical lead in cybersecurity and human factors. And I also lead what is called the Airbus Accelerator in human-centric cybersecurity. And I'm going to tell you a bit about that during the presentation. But when I say I'm double badged, I also work at Cardiff University in the UK. And at Cardiff University, I'm the director of the Human Factors Excellence Research Group and deputy co-director of our relatively new Centre for Artificial Intelligence, Robotics and Human Machine Systems. Lots of my contact details are there on the slides. So thinking about human machine systems in general, I'm just going to give some examples that lots of us will know about. So human machine interface design, human computer interaction, HCI, human-robot interaction, HRI, humans in artificial intelligence, XAI, human-centered cybersecurity, human-centered information security. Now, there's a common feature of all of these different areas that I think you'll all notice, but I've popped some circles on there so that we can all see the human element or the human factor. So within each of these areas, when we're thinking about human-robot interaction, humans and automation and so on, we really have to think about the humans. However, there's an issue which I'm going to talk about. And part of the issue is, despite many systems being very well developed, systems and hardware, there is still what I think inadequate consideration of the humans who are meant to use them. This is not the case for the work we're doing at Airbus, at HUFEX or IROMS, or certainly in lots of other spaces. But I think we need to do a lot more when it comes to understanding how humans interact with systems. And my particular focus is going to be on human security or cyber security when interacting with systems. So designing with humans in mind. Can I give you an example of a project that we conducted at Cardiff University with many other collaborators? And in this example, there are lots of pictures. This project was called Flourish, and Flourish was all about connected autonomous vehicles. So designing, testing autonomous vehicles for empowerment through trusted, secure mobility. Now, the reason that I'm demonstrating this slide is because we didn't try and develop any of these systems and test them without humans as part of the co-design process. So looking at the pictures on the screen, in the top left-hand corner, you've got an elderly person getting into an autonomous vehicle and looking quite scared, some would say, looking quite scared, you know, sort of thinking, how am I going to use this thing? So that's where we started. We then moved on to the literature, looked at human factors principles and lots of other principles for designing human-machine interfaces for autonomous vehicles. But before we actually even got to the drawing board of designing the human-machine interfaces for the autonomous vehicles, we actually had lots of workshops with our participant samples, which in this case were older adults. And we asked them what they think, what they think they needed for effective human-machine interfaces, for secure human-machine interfaces, for usable human-machine interfaces. And then we went through various stages of the design and development process, went back to the user group again after we developed the first iteration, asked them what they think, got some more feedback, and then started implementing these designs into the autonomous vehicles. And in the bottom right-hand corner, you'll see images there of an older adult with particular usability and accessibility requirements using that interface. Now, what happens there, and as we predicted, is things like attitudes, trust, and security. They start on a scale of 0 to 10. They're quite low. And at the start of this 3-year project, they were quite low for pretty much all of the participants that we tested. But towards the end of the project, attitudes, trust, and security in particular were almost close to 10. So all of these things increased as a result of this co-design process. So thinking about risk assessment. So why have I entitled my talk Risk Assessment? Well, if we can risk assess autonomous vehicles, then we can start thinking about this in terms of the likelihood of a risk occurring and the severity of a risk occurring. So in this example, the severity is that there's no market for autonomous vehicles. And the likelihood is, thinking about the likelihood, the higher the likelihood rating, the lower the levels of things like trust, perceived experience, reliability, attitudes, and so on. And likelihood is often linked to humans or intended human users. And it's not just about how well the system performs. So what we're really trying to do is look at that likelihood factor. Can we bring down the likelihood factor that things like trust, perceived attitudes, risk, and security will be high in this case, so that the likely market for autonomous vehicles will be higher? So that's thinking about autonomous vehicles. But let's think about cybersecurity. So in terms of this question, which of the following do you think are the weakest link in the information security chain? Is it employees, people, software, or hardware? Most people, if I was to ask this question, and I had time to ask this question of everybody in this workshop, would say employees, humans, and they wouldn't be wrong. Because it's been identified that the human factors, or humans, are a causal factor in up to 95% of cybersecurity breaches. That's a really scary statistic. That's really, really scary. That's a very, very high figure. Yet the major focus is still on the hardware and the software and its processes, so getting the hardware and the software right, and not so much on the humans. And this is certainly not the Airbus way from the work that we're conducting in Airbus. We need to focus more on humans, designing systems with humans in mind, so that those systems are more secure at the human as well as the software, hardware, and processes level. So going back to my risk assessment example, the likelihood is going to be higher than 1, depending on many factors, such as cyber awareness, cyber understanding, cyber beliefs, cyber training, and the severity could be high dependent on many factors as well. And of course, the ultimate level 5 unacceptable level of severity is that a cyber breach occurs and the person and or the organization is severely compromised. So we need to get this product closer to 0. Now, hardware and software can help to mitigate the severity and help to bring down the level of severity if a human cyber breach occurs, or a cyber breach because of a human action, but we must work to reduce the likelihood of that human factor or the human vulnerability. And that's what I'm going to focus on next. So we do this already across a number of different domains. It's very, very difficult for some people, I think, and I've had lots of conversations with people out there, to accept that we need to cyber risk assess humans. A lot of people are uncomfortable with this as an idea, yet we risk assess so many other things that we are comfortable with. So for example, the health and safety example there of having a chair and a desk and a computer monitor at the right angle, we're all very, very used to this. If we start a new job and we move into a new office, we go through these processes of having the right equipment to do our jobs. Yet some people still find it very, very difficult to understand this from the sense of cybersecurity. But I think it's very important because often susceptibility is linked to suboptimal awareness, understanding, and knowledge. And we need to do this risk assessment process more often. So Airbus have recognized this, that even with the best hardware, software, and processes for cybersecurity, optimizing the people element is key. And this was recognized over 2 years ago when I joined Airbus as a secondee, and launched what's called the Airbus Accelerator in Human-Centric Cybersecurity, which is a first of its kind research accelerator within a major global organization. And just taking a quick quote from the company Chief Information Security Officer and Chief Digital Security Officer, we very much believe that with the right tools and approach, employees can be the strongest link in cyber defense. And we put people thinking at the heart of an organization's security. And just to give you an example of some of the ways we do this before I summarize and come to my conclusions, we don't just do this using scales and questionnaires. Scales and questionnaires have a very, very good and important place to play. We also use lots of hardware and software to try and get the richest data set we possibly can. So for example, measuring people's eye movements when they're interacting with technology through eye trackers, measuring brain activity using EEG, measuring facial expression so we can get an understanding of what people are expressing with their faces when they're interacting with technology, using physiological data such as heart rate, and also using interventions that are based on virtual and augmented reality as an example. So to summarize, it's my view and the view of a number of others that I work with that autonomous robots and systems have to be secure, both in terms of hardware, software, and the people who use and will use them. All automated systems require human input. I'm a firm believer in that. Even when something is fully autonomous, there's still going to be a human somewhere in that loop who needs to monitor that system should something go wrong or should things go right. The lower the level of autonomy, the greater the input required. Though we shouldn't forget that at the higher level of autonomy, the greater the level of human monitoring that will sometimes result in an input action being required. Firmly believe that the risk assessment and mitigation approach can be adopted to better co-design automated systems so that we have a firmer understanding of what the cybersecurity of the humans as well as the systems are. And then we can better avoid cyber breaches. And as another takeaway message is don't assume that we know what the human vulnerabilities are and that they will be the same for everybody. We need to measure and baseline them for all cyber physical technology. And let's not assume that they won't change because they will. And only then can we develop optimal human-centric cybersecurity tools, methods, and interventions that need to be based on these baselines and risk-assessed vulnerabilities and strengths. So thanks very much for your attention. Last slide contains my contact details again. And now I'll stop sharing my screen. Thank you very much.
Okay, thank you, Phil. Very nice talk. So the last talk of the first part is going to the Giulio. So Giulio, are you okay? Yeah, please go ahead.
I should be, thanks. First thing, am I correctly sharing my screen?
Yes.
Right now? Can you see my first slide?
Yes.
All right.
Please
So
go ahead.
thanks everybody. But first, I should never start with that, but an apology. I think they're sort of cleaning the buildings. There might be some noise, but that's it. What I'm gonna do today is I'm gonna talk about, let me remove this, the little pictures because I don't see anything here. All right. About varieties of responsibility gaps in autonomous systems. My name is Giulio Mecacci. I work with Phillip Morgan, the CEO at TU Delft. Actually, the main motor of this work is Filippo. We work at ethics and philosophy of technology within this project called Meaningful Human Control over Automated Driving Systems. I also work at Radboud University, and I teach ethics and the societal impact of AI. But let's get to the point. Responsibility gaps. So in 2004, Andreas Matthias introduced what he called the problem of responsibility gap with learning automata. In a nutshell, intelligent devices equipped with the ability to learn from the interaction with other agents and the environment will make human control and prediction over their behavior very difficult, if not impossible. But human responsibility requires knowledge and control. Therefore, we're facing a dilemma. Either we go with the design and use of learning systems, thereby giving up on the possibility of having human persons responsible for their behavior, or we preserve human responsibility, and thereby we give up on the introduction of these learning systems in society. So more recently, this concern with responsibility gaps has been raised a little bit more in general in relation to automation and AI. So risks of gaps have been identified, not just in relation to the learning capacities of AI, but first and foremost, its opacity, complexity, unpredictability that these autonomous systems generally display. In fact, the question so as to what extent human persons can or should maintain responsibility for the behavior of AI has become a very important, very central question in ethics of AI. But the philosophical complexity, that's what we argue here, of the notion of responsibility is rarely reflected in the debates on autonomous systems. Discussions about responsibility and or accountability gaps are sometimes partial, or they appeal to an insufficiently specified notion of responsibility. Also, the focus on learning automata or artificial intelligence may be too limited. What I argue here is that certain kinds of responsibility gaps, they're just they're due to many factors, and they're sometimes only aggravated by the presence of intelligent autonomous machines. This is really important. For instance, sufficiently interconnected socio-technical systems, such as, let's say, bureaucracy or corporates, that have a limited intelligence and capacity to learn, but they rely on a complex texture of human agents. They might also generate responsibility gaps. So considering different causes beyond artificial intelligence and automation can, we believe, contribute to carve the problem at the right joints and provide better insights towards, well, solutions, possible solutions. Yeah, but we argue that responsibility gaps discussion can be reframed along the lines of different notions of responsibility that have been retrieved in moral and legal philosophy, that tradition. And by doing so, we can identify 4 different kinds of responsibility gap: the culpability gap, the moral accountability gap, the public accountability gap, and the active responsibility gap. For each of those, we have isolated different potential causes. All right, so let's get to the first one. Culpability gap. We call culpability gap the risk that no human agent might be legitimately blamed or held culpable for the unwanted outcomes of actions mediated by autonomous systems. So autonomous systems, intended in the most encompassing sense of socio-technical systems, where there's human agents and intelligent technology, they're entangled in complex network of interactions, those may put culpability practices under stress and prevent the realization of one or more of their goals. So consider, for instance, the autonomous driving systems. That's a typical example. These systems may make the network of agents involved in the driving more complex, or more agents are involved, more unpredictable, because, for instance, vehicles' performance is potentially redesigned by the second on the basis of new data acquisition and processing, and also opaque. So the reasoning scheme underlying these systems' actions may not be easily accessible to controllers, regulators, or even their own designers. So the agents that are operating in such a network, the designers, programmers, drivers, regulators, road users, may more easily find themselves acting wrongly. So for instance, causing an avoidable road crash, while at the same time, within these conditions, having a legitimate excuse. So nobody, not them, could reasonably predict certain circumstances or reasonably avoid a certain outcome, therefore not being open to legitimate blame. All right, this is concerning because the more persons designing, regulating, operating the system can legitimately and possibly systematically avoid blame for the wrong behavior, the less these agents will arguably be incentivized to prevent these wrong behaviors by, for instance, striving for a higher level of safety, awareness, attention, motivation, skillfulness. And the less victims of unjust harm will be likely to receive compensation, that too, right? And this could also make it more difficult for a person to make sense of their moral sentiments in relation to wrongs and accidents, thereby impoverishing their capacity to express moral judgments. It may also feed helplessness, moral skepticism towards the possibility of understanding and rectifying these wrongdoings. And finally, ultimately fuel the desire to find a scapegoat to satisfy these feelings. But what's important here is that the culpability gap is not just caused by the inherent unpredictability of these learning machines, but by the interaction, also by the interaction of all the elements in the network, the different roles they played, the partial contribution they gave towards an outcome. So intelligent autonomous entities with no soul to blame and no body to kick, you know what I mean? Such as, for instance, bureaucracy and corporates, they give an important contribution to generating gaps in culpability. This has been classically identified as the problem of many hands. So intelligent machines play, however, an important role by contributing to worsen the phenomenon, to make it more visible. Automation, algorithmic decision-making, importantly, introduced a new element of technical opacity and unexplainability that makes it more difficult for individual persons to satisfy the traditional conditions for culpability. There can be intention, foreseeability, control. So there's another second gap, important, which is the moral accountability gap. So culpability is just a particularly serious form of moral responsibility, okay? But it's not the only one. Individuals are called often to respond to their choices or actions in less threatening ways. When, for instance, family, friends, acquaintances, they ask them why questions, like why did you do this, why did you do that? But the expectations to answer these why questions from other persons is what we call moral accountability. Autonomous systems of different kinds, they may blur this moral accountability. And this is by creating a more complex and potentially opaque chain of decision-making and action. These systems may make more difficult for individual agents to make sense of the reasons why a certain decision was taken, what their role exactly was in the operation, and in general, whose reasons and what reasoning were governing the system they are part of. In addition, this whole process of technology development and production can be seen as pervaded by this increasing pressure towards deploying proprietary technologies that are designed to be inaccessible to public scrutiny and to the users themselves. So technology developers, for instance, they're driven by the desire to minimize espionage, for instance, maximize the number of customers. It will usually avoid sharing data and engineering insights. Therefore, the capacity of different agents, including the users, to make sense of the logic of the system's behavior may be weakened and sometimes lost. And this is together with their capacity and willingness to engage in a meaningful conversation about what their role is and that responsibility that comes with that role. So in a nutshell, all right, in a nutshell, autonomous systems may make individual persons less able to understand, explain, and reflect upon their own and the other agents' behavior. That's what the moral accountability was about. And the third type of accountability, the public accountability gap. Okay, so another specific form, this is a specific form of accountability that's touched on politicians, civil servants, other agents that are invested with the public function. This public accountability, it's Mark Boven's definition, is that it's a relationship between an actor and forum, and there's an actor that has an obligation to explain and justify his or her conduct, while the forum can pose questions and pass judgment, and the actor that may face finally consequences. So effective mechanisms of accountability, they're there to enhance the effectiveness of decision-making systems. They contribute to the liberal democratic values. They limit abuses of power, like corruption, for instance. They promote transparency, and so on. But there's, for instance, Varieties et al. Recently, I think that was 2018, they presented some challenges to public accountability coming from the introduction of autonomous decision-making systems in AI and in particular in public administration. So traditionally, this is how it goes. Public agencies were organized as like street-level bureaucracies. So processes were managed by individual case managers who had direct contact with the individual citizens, and they had substantial discretionary powers. But with the introduction of this digital decision-making system, these discretionary powers of these professionals, it has, of course, been disciplined, but this has also greatly shifted the locus of administrative discretion from individual public officers to IT experts. They're responsible for programming the decision-making process, to translate the legislation into software. So great power also went to the data analysts, for instance, who were responsible for acquisition and analysis of these data. But this shift raises at least sort of three challenges for this public accountability. So first, the development in IT is often outsourced to private parties, tech giants like Google, for instance. We're not politically accountable and may not be willing to disclose critical information about the functioning of their systems. So secondly, and more generally, the work of the software engineers, the work of the software engineers and the data professionals in these public organizations is usually sort of not visible and not subject to public and legal scrutiny. And finally, far more data are exchanged between the many different organizations that with respect to the past. This makes the problem of many hands, and we mentioned before, more acute. So data coming from different sources, they're introduced and reached at different points in the data chain. So individual citizens may have sort of a hard time to find out who they should turn to if these data are incorrect, corrupted, biased, because this is a collective outcome of a series of minor contributions along the chain. Fourth notion, and I'm done. Fourth notion is sort of identified in the literature in responsibility engineers and designers. This is the tradition. So in a nutshell, active responsibility is a forward-looking responsibility concerns the goals and the values that professionals, such engineers, are supposed to strive for, the duties, things that should prevent from happening, and so on. So for instance, so-called social responsibility of engineers would be a typical example of active responsibility. So one problem with this active responsibility is that while engineers have arguably an individual active responsibility to promote societal good, Their work is embedded in networks with different agents and institutions. They may, for instance, be involved in projects connecting scientists, their academic institutions, or technological companies, or operating on the market. The individual engineers may not have a clear and consistent representation of what their social role is. Are they scientists? Are they technicians and business persons? What are the goals and values they should strive for? Truth, innovation, market shares. They may not even have clear and shared systems of principles and norms and rules to follow. So at a broader level, the introduction of new autonomous systems, they may create two different but related sets of issues. Very briefly. First, engineers and other agents involved in development and use of technology may not be fully aware of their respective moral and social obligations towards other agents. And secondly, engineers and other agents involved in the development and use of technology may not be sufficiently able or motivated to fulfill this obligation they may be well aware of. Okay, so motivation. These two issues together are called responsibility gaps. This is just for your later use. Summary table conclusions. We're not concluded yet. We're just getting started. To wrap this up, actually, sufficient awareness of this complexity has been missing in the debate so far. That's it. Current debates have posed an accent from time to time, one or two of these different problems, one or two of their sources, often not giving sufficient attention to the broader picture. We've seen that there's a complex network of factors promoting the creation of different types of responsibility gaps, and each of these different types might origin from a different set of sources. Focused solutions might be necessary to address these different gaps and avoid neglecting or even creating new ones, okay? We've done some work in there's a forthcoming work where we have discussed a few of the current approaches to these gaps, highlighted their partial nature, discussed the consequences of this partiality, and we have sketched a more encompassing approach based on our philosophical account of meaningful human control. But this is not for today, so I will reassure you. If you're interested, I hope you look out for our paper as soon as it's out. For today, thank you for listening. And sorry, I'm a little late, but thanks.
Okay, thank you, Giulio. Okay. So now it's time for the discussion. So I'd like to show you some questions and so on. Okay. So can you see the comments? Actually, I got only 3 speakers. The last one is almost no time. So therefore, okay. So I may start answering to the question for me. So I got the question. So do you believe that in future the bench android will be able to express its emotions autonomously in response to the recognized human emotions? Of course, my answer is, as I mentioned, currently the Leonardo da Vinci is just a teleoperated one. So at least, as you mentioned, the capability is a recognition of the human emotions and autonomously respond to the recognized emotions. So if we suppose that we can design some sort of the recognition of the human emotions by the facial expressions or the face images, and also we prepare for some facial expression to the robots. But the point is how the emotion expression is real or not. That means really some android have emotion itself or not. But that's some real issue. So therefore, my answer is that some current artificial system superficially shows some response to the human recognized human emotions to some emotional expression, but not real emotion yet. Therefore, I suppose that one of the possibilities for me is to think about the pain nervous system to feel pain, some sort of sensations. And these sensations may contribute to some design of the some emotional system of the artificial systems. But still, we need some sort of the materials and also the environment and also the learning system too, of course. Okay, thank you for your questions. Okay, to the Raja, could you prepare for to answer?
Yes, thank you. I have 2 questions. So
Yes.
the first question is, in your machine learning system, all the intention eventually came from the training data. Then what kind of legal status is to be given to the training data? Well, first, I wouldn't use the word intention to designate what is coming from the data. The data is knowledge. It's a kind of knowledge-based, which is possibly curated by humans, by the way. I mean, images, for example, can be labeled. And in this process, there has been a choice made by humans to use this data. So they should, of course, have responsibility on this choice, choosing this data. But sometimes, especially, for example, for continual learning, you cannot control the data input. It's still not the intention. It's about the data. Then the system might learn from data which wasn't really controlled by humans. However, once more, the data is not all. It's the learning process which transforms the data into decisions, into actions. And this comes from the designer of the system. To answer specifically what kind of legal status is to be given to the training data, I don't believe personally that the training data could have any legal status. It's a set of knowledge, data, whatever you want to call it, that can be curated, can be validated, can be stamped, can be certified. This is the maximum legal thing that you can do about it. And if it is not, it is also the responsibility of the designers of the system to decide to use it or not, because there might be also some selection processes to remove data which is corrupted. I'm not saying it's easy. I'm saying this, what is to be achieved. About the second question, would it make sense that a legal personality similar to what we have for companies, for example? Well, a logical entity putting together the many human agents and company involved with the robots. Why not? I mean, of course, again, you can build a kind of corporation, association, whatever, that involves all these stakeholders, and therefore use this entity as the legal personality or legal agent to be liable for those issues. I wouldn't see this as something really new to the current situation, because we have already companies which are held liable for their products. Then you have here a different kind of association, which by itself would be also held liable. I hope I answered the questions. Thank you.
Okay, thank you, Roger. Okay, so I suppose maybe as you know, the Professor Hiroshi Nakagawa and also the Fabio may have another question to the answers. But anyhow, so we may answer or respond to the after the workshop. Okay, so next one is the Phil. Could you prepare for the answer to these questions?
Yeah, sure. Can everybody hear me okay?
Yes.
Brilliant. So I think the question was, can you elaborate the risk reduction point about soft and hard constraints for human-machine interface design? So if I give an example of hard constraints, I'll take hard constraints as the key example. So what I mean by hard constraints within human-machine interfaces are design features that are factored into interfaces that make it a little bit harder for users to interact with those interfaces. Now, some may ask, why would we want to make things harder? That's surely not a good thing to do. But what I mean by harder is mainly in terms of accessing information. So for example, some information in an interface that needs to be thought about or to a deeper level or memorized, for example, maybe it shouldn't always be the case that that information is immediately available for individuals to look at and, dare I say, automatically process. Because what happens is if information is immediately available, we often will automatically process it at a very, very surface level. And then we don't think about it enough. We don't think about it enough. And if we're queried or questioned about that information in the future, or we need to retrieve that information from memory, we run the risk of forgetting it or being even more risky when using that information with very, very small costs that we call hard constraints. So for example, masking some information on the screen such that you have to pay a physical cognitive cost to access the information to view it could be in the realms of 1 to 2 seconds, that's all. There are very, very powerful shifts in the cognitive strategies that we use to then process that information. We process it to a deeper and more meaningful level. We're more able to remember it in the future, and then we're more likely to spot potential issues with that information. So for example, if it's malevolent, if there's something cyber risky about it. What happens then in terms of the risk assessment point is we can measure things without hard constraints and find whether the likelihood of the risk is higher. We can then introduce hard constraints and measure whether that likelihood comes down. So hopefully that answers that question. I won't talk about the soft constraints example in the interest of time. But thanks for the question, really good question.
Thank you, Phillip. Okay, so the last question to the Giulio is that so a little bit longer comments for this question.
Yeah, I'm not entirely sure. Actually, this question is just for me. Maybe it's like a general kind of to all the panelists. But still, because I find myself to be in agreement with like 99% of this question. So I agree. I agree that legal liability in the sense of a pragmatic disposition towards requiring some damage, some compensation is it's really just a pragmatic kind of thing. But it's separated from moral capacity, but I'm not sure I've been talking about it on either consciousness, metaphysical autonomy. But the thing is, this is the thing I want to say. Although legal liability might be in an extreme sense of it, something that is a pragmatic solution. Sorry. Pragmatic solution to the to certain incapacities to address problems in the attribution of moral responsibility. What we should strive for is to identify as much as possible a moral locus of responsibility, because moral responsibility has extra values that I think I have identified maybe a little bit in my speech, but they can be identified as being valuable inherently. So I hope this clarifies a little bit. It addresses at least part of this question, with which I, again, am mostly in agreement with personally. So if it's for me, I would argue that I mostly agree with it.
Okay, thank you. So
if you have time, can I add something here?
Yeah, sure. Go ahead.
Okay. Thank you, because indeed this is a question that is very important, and I agree again with what is said here. As Giulio said, I would like to add something. It's indeed, you are completely right, Emma, that it's a pragmatic way, and I think I mentioned this, but the point is that with robots, and this is really specific to robots, there is something different, because at the same time, we tend, many researchers do, and the general public as well, tend to project on robots properties, capacities that are human, and people think that the robot has taken intentionally some decisions, that they have a moral reasoning. And when we bestow the legal personality on robots, we contribute to this confusion. This is why it has a very specific topic here. And all the more that if we give to the robots human appearance, this is why I'm saying that human appearance is an added complexity to this, because when you see a car, well, you could still think that maybe it's not really acting in a human-like way. But when you see a robot that is an android, then the confusion grows. Therefore, I do believe that we should put very clear bounds on what we can bestow in terms of responsibility, liability, legal personality to machines and robots. Thank you.
Okay, so still we have 12 minutes to discuss. So do you have any questions among the speakers or any questions? It's okay? Nothing? Yuji, do you have any other comment or questions after this one? No?
No.
Okay, I see. Okay.
I can give some comments, but actually what I want to say in my talk is really related to all this. It's really about how to think about human agents and artificial agents, and how we should address the ethics linked to that. Is it about the ethics in the artificial agents, or should we think about how to combine these two forms of agents?
Yeah.
So if I intervene now, I will spoil my own talk.
Okay, just wait. Yeah, that's a very, very important issue of something. Of course, Roger mentioned about the legal personality or something, and from the sense of the legal system, so robot is still very, very hard to localize the position to the legal system inside one. Actually, the point is that I suppose maybe at the beginning, at least we should get used to living together with them first, and then think about how to living together with many different issues or something. So my point is that, of course, we'll think about these issues beforehand, but I like to introduce these artificial systems into our society, and then let's think together. That's my point. So in that sense, of course, sometimes my talk is some contrast to the Raja's one. So I like to intend to make the discussion much more productive. So of course, as a researcher, I like to seek for some ways to make the robot much more intelligent, much more close to us. But at the same time, we have some conflict or the design conflict about how to design the robots and so on. Because the human being is so selfish sometimes, not so ethical something. So therefore, we have some sort of conflict issues of the designing something. But anyhow, that's a very, very important issue to discuss in this workshop. Therefore, we would like to keep these issues as the second part of the discussion. So even though we have almost 10 minutes earlier, the schedule, that's very, very exceptional. But Peter, are you okay to give your talk already?
Yes, I am. I also thought that in the new schedule it had to start at 10:15, so maybe I was wrong.
Okay,
So
okay.
in that sense, we are doing quite well.
Okay.
Shall I share my screen then?
Yeah, yes.
Minoru, you have an additional question, actually, if we have time. I've seen it on the chat window.
Oh, really?
Yes.
Yes.
It's, do you envision a kind of continuous scale of increasing consciousness, and where you think we are? Meaning both for natural and artificial agents.
Yes, that's a very, very hard question. Okay, actually, I intend to the design as the Italian philosopher, Vico mentioned that the real understanding is possible through the creating something. Therefore, of course, I try to intend to the some continuous scale of the between the human beings and some artificial agent. Of course, I suppose that there is some big some difference between them. So some sort of my case, just say artificial consciousness. Okay, so artificial consciousness and the natural consciousness share some part. there's some part could be the essential part of the consciousness. That's my intention. Therefore, hopefully, like to have scale, the continuous scale between the natural consciousness and the artificial consciousness. But I suppose at this moment, artificial consciousness is not so well developed yet. Therefore, just we say in your word. So ideally, we like to have some continuous scale between the human consciousness to the artificial consciousness, but still it's not so realistic yet. Therefore, first I would like to design the more realistic artificial consciousness first, and then try to compare, and then keep was on derive some essential part, the part of the consciousness. Okay, did I answer to the question?
Can I suggest that there might be an element of discontinuity in relation to consciousness because the mediation of language? So I think a continuum is unlikely given what language can endow and how thought is mediated by language and then consciousness. Not that I've got the answer to the nature of consciousness, but I think that is a crucial variable and a point of discontinuity.
Yeah, thank you. Yeah, because actually the language or the capability within the world, the language capability is another essential issues. Because I like to, today I just show the ecological self or interpersonal self or social self. But between them is we have the narrative self. So make some story about its own. So also I suppose maybe consciousness is related to some sort of the narrative self. And narrative self is related to some language capability too. So therefore the language is another aspect of this one. Yeah, thank you. Thank you for the point. Wow, okay. Okay. So I'm just reading some comments. What does, so it's
robotic pollinators. That's
yeah.
very specific expertise that we need to answer this question.
Can you do that? Okay.
I'm afraid I'm not quite an expert in robotic pollinators, but it's of course very interesting since the insects seem to be dying, and probably this question comes from somebody who's working on robotic pollinators. So it's a very important theme. But
okay, so we have the 5 minutes earlier the schedule, but we may start at the main embedded speaker of the Peter Paul Verbeek. Okay, can you?
Of course, I will share my screen. Let's see if I can get it running.
Yes.
So do you see the slideshow?
Yes.
Yes, wonderful. Thank you. Yes, well, as I said, what I would like to do in my talk is to address the relations between human agents and artificial agents as a basis for asking ourselves how we could address the societal and ethical questions about robotics the best way. Because I think very often the questions are about, well, some kind of an opposition or a tension between robotic systems and human beings, where the question is to what extent robots take on forms of agency that used to be limited to humans. And the question then is, how far should we go? Or can we design ethics into the robot as if they would act like a human? And what I would like to explore is actually how these two forms of agency, this artificial agency and this human agency, start to merge. And how maybe the better frame to address ethical issues about robotics is a frame in which it's about understanding how we could take responsibility for our dealing with robots, and how we can understand how they change our relation with the world. So it will be kind of a phenomenological analysis with a big word of the intentional structures of the human-world relation as mediated by robots. How do robots interfere in how we take up with the world, with other human beings, with practices in healthcare, etc. So maybe it's good to make kind of a general start. I think often people now say that we live in the time of the fourth industrial revolution, which means that we live in a time of cyber physical systems. So after mechanization, mass world, automation, we now live in a digital world where the digital technologies become also physical, where digital technology start to merge with our everyday life. And in Japan, as I heard, there's now even a big discourse about this fourth revolution resulting in society 5.0, a fifth type of society. After the hunting-gatherer society, and we got the agrarian society because of the invention of the plow, and then the steam engine took us to the industrial society, the computer to the information society, and now AI or robotics take us into the digital society or the super smart society. Kind of a deterministic picture of history, of course, so I think it's much more nuanced than this, but it's an indication that our society seems to be changing as a result of new technical developments. And maybe the most important thing here is that technologies start to work on us in a different way. The older concept of technologies that we use, where technologies are actually tools in the hands of humans, where humans have the intentions and technologies are just instruments for us to use, like here David Bowie with the first Macintosh computer, that configuration doesn't really work anymore. Technologies start to merge with our environment in smart environments, smart cities, and try to work on us from the background, or they merge with our bodies, like the brain implants, or they augment our interaction with the world by giving us this second layer of information, and we have kind of a bifurcated relation with the world. And we look through the glasses, but also things add elements to the world around us. Well, maybe the most important theme for us here is the theme of interaction. Interaction really as interacting with a robot that also works back on us, and also cooperation. Working, for instance, with an AI system, an expert system, that, for instance, could help a doctor, where both the doctor and the system take a look at the patient, as it were, and where the doctor also has to try to make sense of what the AI system is giving to the doctor. But it's totally new configurations of humans and technologies that then, of course, raise the question of, okay, how should we understand this? And what kind of agency, what kind of consciousness comes here? So this is, of course, a very philosophical picture. Le Penseur, I think Raja will like it. I think he lives quite near the museum of the sculptor of this beautiful picture, Rodin. What is happening? And I think that this is a nice picture, not to ask ourselves, can the robots think like humans, but more, what does it mean if robotic thinking, or at least reasoning or arguing or acting, starts to merge with us, with our actions? An example that I often use to explain this is also actually with a Japanese example. I think this is a former Minister of Health in Japan who gets food from a feeding robot, where I think many people get horrified by the idea that the robots would actually start doing this, that robots would take care of elderly people rather than humans. Here we feel the opposition between humans and robots. Care is about vulnerable people, and do we really want to leave care to robots? People have associations with Modern Times, the movie of Charlie Chaplin, where there's also this feeding robots feeding the laborers as fast as possible to make sure that they can go back to the conveyor belt and the production lines as fast as they can. And this opposition, I think, is not very helpful. I think a better question is here, how does healthcare change under the influence of robotics, and in which ways can we include robotic systems in good forms of care? If you know people who actually are not able to eat by themselves anymore, you can also see something totally different in this picture. You can also see a person who used not to be able to eat by himself, now to have regained that option. And that's quite something. It can be very humiliating for people to have to be fed by other people. And in our design lab, we even designed an algorithm for such a robot that also enables you to eat in a team of people, and to make eating social again, where the algorithm just follows the conversation at the table, and when there is a pause coming up, it gives a bit of food to the person behind the table. I think that's a different frame. That's not asking ourselves, can the robots do the care instead of the humans, but how to integrate the robots in healthcare. Well, of course, in the field of AI, we see the same questions. Can an algorithm, for instance, be a judge? But also the question maybe is more, how should a judge deal with AI in the legal system? If an algorithm or an AI system can make an analysis of all the earlier verdicts and then suddenly, well, tell the judge, well, actually, all people before you have made this decision, so this is probably what you should do. How could a judge possibly go against such a verdict? So how to understand here also the interaction between humans and AI is maybe more important than asking ourselves, can an algorithm be a judge just like a human could? And maybe then it's always good to keep in mind that the ways in which we are living now, the ways in which we are working with technologies, was actually also the result of earlier technologies. That this whole idea of human autonomy, where we need to be in charge and technologies need to be as instrumental as possible, that frame is maybe not always the most adequate one. Now, if you think back from AI to the past, I think AI is obviously well, you could say a thinking technology, a cognitive technology. It influences how we understand the world. But we have seen that before with technology that we have come to find really normal, like the printing press or writing. Writing has had a lot of impact on our memories. We can indeed not memorize as much as people could do before we could write. But at the same time, we have this artificial memory, all the bookshelves, that help us to remember a lot, but in a different way. The printing press made possible the scientific revolution, the democratization of knowledge. It moved out of the monasteries into the world. And we have come to find that normal. We don't experience that as a threat to human beings, even though, well, in the time of the Reformation, the printing presses were destroyed sometimes by the Catholics to fight against the Protestants who could spread their ideas with the help of the printing press. But I think this shows that we can somehow think technology into the human being. Let me take 2 steps to understand how we could do that. The first is to see how we are currently really trying to demarcate the differences between humans and robotic systems in many ways, and then also try to show you how that gets stuck and how we could find an alternative way of analyzing the various types of interactions that we have with robots and how that actually works in our interaction with the world and the ways in which we take up with the world, understand the world around us. I think that whole theme of demarcation is really crucial. It has always been central, actually, in trying to understand artificial intelligence. It all started out, of course, with the Turing test, where the main question and the main test you can give to a computer is, are you almost like a human? And if we cannot tell the difference between the two, then of course, well, the computer passes the test and it meets the criteria that we have to call something human or human-like at least. And of course, this has become, in a sense, totally outdated. In the old times, the computer needed to be behind the wall. But now, of course, we can just interact with systems that are really human-like. Or people even get a reverse Turing test, where we have to prove that we are not a robot online, rather than to prove that the robot is a human being. Or Google Duplex, that can make a phone call on your behalf with a voice. I mean, you must have seen those movies online. Where it calls the hairdresser, and the hairdresser really doesn't know that it's speaking to a computer. So this is maybe the next step of the Turing test, right? So we hear something, and it's really hard to tell also from your sensory experience that you are not interacting with a human being. And this scares people off. On the other hand, from the other angle, we have the uncanny valley. It's a totally different angle of demarcation. Where the Turing test really wants computers to be as human-like as possible, the uncanny valley teaches us that we should also be careful with that, because there is this valley of horror that we need to cross. The more it looks like us, the scarier it gets, until it's so naturally almost human that we are not really scared. But I think the very interesting Da Vinci robot that Minoru showed at the beginning can also be a very scary thing for people, unless you can hardly tell that it's a robot. And there's this whole discourse about dealing with autonomous systems also, where it's about the humans and the loop. Should the humans be in the loop, on the loop, out of the loop? So I think it's all, well, attempts to control technologies and also to give humans a very specific place, a very specific role in that interaction between humans and robotic systems, avoiding that ultimately, indeed, we might be somehow redundant, we might be outdated, robots might take over what humans are. And so the Turing test, the uncanny valley, the idea of the human beings in the loop, or the idea of replacement, it's all attempts to demarcate us, which means that maybe the technological developments of this time have taken us to a point that we really start to question what we are because of the new abilities of the robotic systems. Well, we saw the very nice introduction by Raja also about giving personhood for forms of liability to a robot. I think what scares us up is as soon as we start to do that, as soon as we start to cross the divide between humans and robots, we make a lot of mess in ethical theory. Once a robot becomes a person, like in Saudi Arabia, they did with Sophia, and then suddenly, well, a person has agency. But yeah, can a robot have agency? And what does agency then mean? Does it tell us something about human agency? Agents have responsibility. So can robots have responsibility? Well, we've seen this question as well. Can we design it, or is it about our responsibility for the robots? And of course, then persons have human rights. So what constitutes a human right? And should we have robot rights? So does that mean the work of Minoru also shows that if we start to design robots that feel pain, do we at some point reach a point at which we should conclude that we should stop here because they feel too much pain? And how can we give a criterion for that? Persons are part of a democracy. So how can we include robots in our democracy? Well, I mean, this is an endless set of questions. Once you open up the notion of personhood for non-human agents, it becomes messy. And I think this is a challenge for philosophers, of course, because the main concept with which we have always done ethics now suddenly start to shift. But at the same time, it also shows how scared we are and how lousy we still are in understanding the connections between humans and robots. The frame is still, can they take our place? Can they do what we used to do? And we forget to ask, how do they change us? How do we interact with them? Like we have learned to live with the technology of writing and the printing press, how can we learn to live with robots? So I think that also means that we need to move beyond that frame of the robot as an other, as alterity. A lot of robot ethics is really about that. But there are so many different types of interactions with a robot than just encountering the robot as a different person. So that's why I think it's important to analyze the structure of human-robot relations. And that can help us to understand better how to take responsibility for that as well. So from demarcations to relations. And also moving from the framework of a struggle or a fight between robots and humans to more of a cooperation. The interesting thing is, if we look to the future, the robots scare us off. If we look to the past, we actually try to understand the people who lived before us by looking at the technologies that they used. And the hand axe tells us a lot about how people lived before us. And we don't see that as some kind of a threatening, alienating technology that might take over the role of humans. No, by reading the technologies, we read what kind of humans used to live in those days. And I think that introduces a framework that can be helpful. Technologies are not opposed to humans. Technology helps to shape how humans can be human. They mediate our existence. And so the framework for robots should also not be the humans versus the technologies and who's going to win or something, and where should ethics draw the line so that the robots don't interfere too deeply into the human sphere. It's much more about technologies connecting humans to the world around them. A feeding robot is not replacing a human, but is actually reorganizing how a person who cannot use his hands or her hands anymore can still eat. And therefore, it also reorganizes the relation between the patient and the doctors, the patient and the nurses, the patient and the family, patient and his own life, his own body. So this framework of mediation can probably help to understand how robots play a role in our society. So let me go through a number of configurations of humans and robots then to understand those mediations. And then maybe the first configuration to start with is the interaction between a person and a robot. With an example from a Dutch documentary, a robot that keeps elderly people company in their homes. I mean, this was in the Netherlands quite a famous documentary because people got really upset by the idea that lonely elderly people, well, would be given the company of a robot rather than getting human care of their own children, of their own neighbors. Is this really the kind of society that we want? So what kind of interaction can you possibly have? I think just if you try to understand what's happening here, for me, the interesting thing is also to see that it's not just alterity, like dealing with, I don't know, an ATM or something that gives you money, but there's a form of reciprocity in the human-robot relation. And so the intentional structure, if you want to use those big philosophical words, is not only that humans are intentionally directed at the robot, but the robot is also intentionally directed at us. So what can that be? some form of reciprocal, how do you say that, intentionality. That would imply that there could be something like robot intentionality. Could we really conceive of that? Let me go back to an author that was also introduced by Minoru at the beginning, Merleau-Ponty, the French phenomenologist, who wrote very interesting things actually about interpersonal communication at the very end of his life. Well, text that he couldn't even finish before he died, the visible and the invisible. He wrote very interesting things about the flesh. The flesh as actually, well, the stuff that we are made of as humans, and that conditions the possibility of interpersonal relations. We know that other people are also made of flesh, of matter. They're not only minds, they're also bodies. And so quotes like, he himself who looks must not be foreign to the world he looks at. We are made of stuff just like the world around us is made of stuff. And my hand, while it is felt from within, is also accessible from without. It's tangible for my other hand. So we can touch our own hands, and that, well, makes us an object and a subject at the same time. We are a touching, feeling entity that also feels ourselves as an entity as it could be felt by other people. And so that makes him to claim, as soon as I see, it's necessary that the vision be doubled with a complementary vision, myself seen from without, such as another would see me, installed in the midst of a visible, occupied in considering it from a certain spot. And he continues, we see the things themselves in their places, and at the same time we are separated from them by all the thickness of the look and the body. And so the first insight is that we can only perceive because we know that the others can be perceived as well, and we can be perceived by the others too. There is some kind of reciprocity, and then there is also an interface between us and the world, which he calls the flesh, and there's kind of a thickness of the body. We are still separated from the world by our skin, by our body, and it is that the thickness of flesh between the seer and the thing is constituted for the thing of its visibility, as for the seer of his corporality. It's not an obstacle between them, it's their means of communication. So a lot of quotes to show that there is this interesting dimension of interpersonal relations conditioned by the fact that we are made of matter, which also makes it interesting to think about human-robot relations, because they're also made of matter. But they, of course, are not made of living matter, but they are made of techno-flesh, you could say. So what does that mean then for robotic intentionality? I also think here it's interesting to take into account that idea of mediation, where Donaidi speaks about technological intentionality, which actually does not mean that technologies have intentions to act or something, but that technologies can have ways of being directed at the world because of their sensors perceiving this and not that aspect of the world, for instance. And it could also mean that if we try to address human technology relations, then the question is not, do the robots have intentions, but more, how does our intentionality towards the world get shaped in interaction with the ways in which robots are directed at the world? And so it's actually about mediated intentionality. It's about also how robots, well, inspire our frameworks. And so a company robot has a different type of body than a human being. And in that kind of, interaction we have with it, it's unavoidable that there is this different type of flesh, which gives a different kind of reciprocity between a robot and a human, which can never constitute a real otherness in that sense. But that's not the issue. The issue is how the robot will interfere in our interactions with other people in the ways in which we make choices and decisions. We understand the world, even at the ethical choices that we make. So rather than asking ourselves, do robots have intentionality? The question is more, what does robot-mediated intentionality look like? And then in fact, the configuration of cooperation is maybe more inspiring, because that's typically what we do when we interact with a robot. We work together with a robot. Yeah, maybe I try to take as many Japanese examples as possible. the Paro robot. I think also a very inspiring example for many people, where some people also have used that frame of Paro replacing human care, where in fact, the opposite is true. So Paro is a robotic seal with a lot of sensors, and it's warm, it breathes, it makes sounds, it interacts with you, and you can cuddle it, and well, it's a very nice type of interaction you have with it, and especially people with Alzheimer's disease, with whom it's harder to have a more cognitive interaction. They can really benefit a lot from interacting with Paro because of the affection that it gives you, and it really interacts with you. So rather than saying, oh, why should Paro take the place of the nurse or of the family, you can also see that actually Paro helps nurses to take care of elderly people in a better way. The sensors in Paro can help you to also read the mental state and the physical condition of the person dealing with Paro. So here what you actually see is some kind of a intentional structure where both the human and the robot are directed at the world, in this case at the Alzheimer patient. So there is this joint intentionality, as it were, where also the key question is how we understand that jointness of the intentionality itself. So the robot is directed at the world, the human is directed at the world, and there's also an interaction between the human and the robot where the human tries to understand how the robot is related to the world, but the robot also needs to anticipate how humans might want to be related to the world. Paro needs to give information about the elderly person, and actually Paro needs to do things to the elderly person that human beings ask Paro to do. So that's a totally different form of intentionality. It's not just the robot has a relation to the world and we have that as well. There's some kind of a triangle that helps to shape how we interact with the world. And that's a new configuration. I think really a configuration in society 5.0, the hermeneutic triangle, where human interpretations of the world are doubly affected. So we understand the world and we have a specific role in relation to that world, but also with the robot, and that helps to shape also indirectly how we understand the world. So this triangulation that you then get implies that we have to learn to read how robots take up with the world, and actually that we also need to understand how we take up with the world in a different way mediated by the robot. So Paro changes how nurses or we ourselves take up with elderly people, like expert systems reconfigure how doctors engage with patients, because they have to make sense of what the algorithms think and why the algorithms think in order to reach their own decisions. So a triangular form of intentionality, maybe that's the most important thing to take into account here. Now, we can even expand that with also an expansion of that human technology world relation ID. And so this is work that I've been doing with one of my former PhD students who's now actually at Delft. So you might know her, Giulio, Olya Kudina, where we try to work on the idea of what we call the hermeneutic lemniscate, where you try to show that actually the old idea of the hermeneutic circle, which is quite a philosophical concept to understand interpretation, and which actually says that if you interpret something, then in that interpretation, the world changes for you because you interpret it in a specific way. But then the world also forms a context for you to be there, which also makes you, as it were, a different form of interpreter. As soon as you watch the moon through a telescope, suddenly the moon becomes a scientific object and you lose the old ideas of the old Greek how do you call it, cosmology, and then suddenly you become an observer, etc. And so there's always this mutual shaping of well, the interpreter and the interpreted. And when technology mediates that, we get a lemniscate. So humans have to make sense of the technology. And in this case, we have to understand how Paro deals with the elderly person. And the technology has an interpretation of the world. Paro has a specific way of dealing with the elderly person, which also makes the elderly person for us a new type of patient. We understand the patient in a new way because of the way we understand how Paro deals with the patient. And that way of dealing with the patient also helps us to give Paro a place in healthcare. And so the arrow goes back from the world to the technology. And that actually also changes the role of human beings in healthcare, the expectations that we could have of people in how to deal with Paro. So by moving through this 8-shaped figure, we can see that interpretations of the world continuously get reshaped in this complex triangular intentionality that exists between humans and robotic systems, and which also can be a basis then for re-articulating the responsibilities and the values that are at stake in these systems. So let me go to the last example, yet another configuration of humans and robots. So beyond the interaction that we saw and the cooperation, there's also something like re-embodiment, where robots embody a form of, you could tell presence. So being present at a distance through a robotic system that somehow gives you a second body, as it were, through which you can be present at a different location, like a robot in a hospital that enables a doctor to visit the patient on a distance, which then gives yet another configuration and another challenge to understanding that hermeneutic structure. So it's not just alterity, us and the robotic system. Actually, the doctor is present through the robot with using a controller to operate the robot, but also to understand how the robot sees the world. So there are three intentionalities here in a linear way. The doctor operates through a controller, and that controller operates a robot, and the robot has an interaction with the world. There's also three types of intentionality at stake there. The doctor needs to learn to read the controller, and also, of course, the displays that there are, and also needs to have an awareness of how the controller is related to the robot in order to understand how the robot sees the world. You can also see this, for instance, for a drone pilot, where a drone pilot needs to operate the drone, look through the eyes of the drone, as it were, through the cameras. It also needs to understand how the controller that he has can work on the drone, and he or she has to learn to deal with the controller. So it's a really complicated set of interactions between humans and technologies, where a lot of interpretive steps take shape. So it's not well, here it doesn't have the shape of a lemniscate or of some kind of triangle, but this is more linear. But there are three mediations adding up to each other. And of course, then here, that whole idea of the flash also pops up in a new way, because we just saw with Merleau-Ponty that it's about personal interaction, interpersonal interaction, conditioned by the fact that we are also material beings. We are an object and a subject at the same time. We are perceiving, and we can also be perceived. And of course, here, there is an interpersonal interaction, but mediated by this third element, a robotic body that somebody can take to interact with another person. So for Merleau-Ponty, this is a situation of some form of a cross, of a chi. So that's why it's called a chiasm. Where in Merleau-Ponty's work, we're always perceiver and perceived, and the other person is also both perceiver and perceived. So that's why there is not a line between two people, but cross. And the interesting thing is that also that cross here can be mediated by technologies. A robotic system mediates this chiasm, mediates how we perceive and are perceived at the same time. And the mediating matter here used to be in that thickness of the flash that we saw in the earlier quotes. But here it's, of course, techno-flash. So how does this techno-flash reorganize how we are perceiving and perceived, and how the other person perceives us and is perceived? So this is not a dyadic relation, but a chiasmatic kind of relation, where also the mediation of touch and being touched, perceiving and being perceived changes, and also the way in which we are constituted for the other and the other is constituted for us takes a new shape. So the reciprocity changes, and the robotic systems, drones, etc., give us different senses that also work as different types of media in our interaction with the other people, which has then a lot of hermeneutic implications. And there's three steps in mediation: the user-controller relation, the controller-robot relation, and the robot-world relation. And in all those relations, there is a mediation of interpretation taking place that ultimately also mediates the chiasm between two people. Minoru, how much time do I have left? Because you're muted. Sorry, I think I'm almost done, right?
Yeah, almost done.
Okay. Yeah. I can go very fast now to the end of my talk. Then I will try to move to the ethics question that I want to ask. To finalize with that, that can be very fast.
Go ahead.
So we have seen several rethinkings of human-robot relations, where the frame is not humans versus robots. Can robots do what humans used to do, and should ethics be a boundary guard between the two? The question is more, how do humans and robots together constitute new relations? And it also implies for me a different framework of doing ethics. Ethics should here not be about which kind of robots should we have and which kind of robots should we not have. And I think it's also more than just value-sensitive design, which is also really important, by the way, embedding values in the design. It's also about guiding technologies in society. And that's maybe a framework that we need, guidance ethics, that we're also currently further developing in our design lab in Twente, where we try to have this 3 steps in dealing with ethical issues. First, to describe the technology in its context as well as you can. Then organize some kind of a dialogue. It's also a form of citizen ethics, you could say, where the ethical expertise is not only with the ethicists, but you also try to get it bottom up. And we try to see what the mediations are, the effects of technologies on actors, and what kind of values are at stake there. And once you have that, in order, once you have a good analysis of that, you can try to feed that back, of course, into the design, to work on a redesign and make design a learning process, but also you can equip the user with insights in the workings of technologies on themselves, and also change the environment, embed the technology in a different way in our society. And I think that's extremely important, especially since the digital revolution is this worldwide revolution. At UNESCO, I'm also quite active in the Ethics of Science and Technology World Commission, where we try to deal with these issues. And that's my last slide, which I want to show, because I think addressing all those values that are at stake, if you try to analyze the new intricate connection between humans and robots, the values have a worldwide scale, and the value frameworks are not identical everywhere in the world. And organizing a worldwide discussion where the frame, especially about AI, is not only about is there some kind of a competition between China and the US, and is there a European third way, but where we try to have a worldwide framework where also the southern part of the world takes place and all values can have a place. I think that's extremely important to move beyond the frame of the robot versus the human and try to really shake hands with the robot and integrate it in a responsible way in our society. Thank you.
Thank you, Peter, for actually, I had a mistake, the time slot. Therefore, now the 15 minutes behind the schedule. So sorry, that's my mistake. Okay, anyhow, thank you for your very, very impressive talk. And I suppose maybe we have some issues to discuss after all talks then. Okay, so next speaker is François. So it's okay. Are you okay?
Yes, I am okay. I can share my screen.
Yeah.
Just to find this. Do you see my screen?
Yes.
Okay. So hello, everyone. I am François Goulette. I am a professor at Mines Paris-Tech. It's a French engineering school, part of PSL University. And I'm a researcher in a robotics lab. And I will talk today about an issue about the trolley dilemma. Actually, my first concern was to consider teaching ethics at tech students. And then I came across this problem. So I will start talking to you about teaching ethics at tech students. Actually, as you know, robotics and artificial intelligence are new technologies that provide a huge power on others, on society, and on mankind. And actually, it can be used for good or evil. And also, I think something which is quite important to understand is that one can do harm, even not willing it, by negligence, by ignorance, or by unconsciousness. So I have two citations. One is fun and another is more serious. The first one is, with great power comes great responsibility. It's a quotation of Uncle Ben in Spider-Man in the 60s. Actually, I think this quotation is more profound than it can mean. And I have another one, more serious, from Rabelais, a French writer in the 16th century, who said, "Science without conscience is only ruin of the soul." And actually I had this reflection going on, and I was considering that robots and AI usually are fun for tech students. If you consider the upper part of this slide, you can only think that autonomous vehicles, they are fun, it's really exciting. Martian exploration with robots, it's fun. Social robots like this, it's fun. But we usually forget to think about other applications of robotics or artificial intelligence, like lethal robots. It's less fun. Social scoring, like you have already in China, where you can, with video surveillance, attribute scores to people regarding their behavior. Also, justice assistance, and this example is an existing one, where you have flawed justice assistants. So robots and AI, they are not always fun. And we were considering giving a course on ethics and AI in a broad sense, including robotics. So just in a few words, PSL University, because maybe you don't know this name, it's a recent university, inner Paris. It's a recent one because it was officially really administratively created this year. And it gathers several institutions from Paris, like Mines Paris, which is my engineering school, École Normale Supérieure, it's a very famous institution in France, University Paris-Dauphine, and others. So they have 16,000 students, and it aims at top international rankings. So you may hear this PSL University in the coming years. And so we were willing to give a new course on ethics and AI. And we settled this year a course at Masters of Science level, multidisciplinary with philosophy, ethics, law, computer science, and practical cases based on real cases, real products like software, like autonomous cars, like existing products, not just virtual ones, to consider these questions. And it was also for several applications like in medicine, autonomous vehicles, retail, justice, finance. And it's where we were setting up this course that I came across this question about the trolley dilemma I want to talk to you about today. The trolley dilemma is something that you have probably heard of. It was formulated originally by Philip Morgan in 1967, so it was far before all our robotic system of nowadays. The trolley dilemma is a thought experience, which means virtual experience of the mind for ethics related questions. And it states, it is stated this way. There are several ways to put it, but the original one was this one. You have a trolley that had brakes which are not working any longer, and is going to hurt several people and maybe kill people. But based on the tracks on which it is going, it may kill 5 people or 1 people. And you have a railway shift with someone, you are this person, and you may choose between having 5 people killed or 1 person killed, or not do anything. So this trolley dilemma actually is very popular in autonomous driving ethical issues. And I just want to show you this small video that maybe you have seen. It's a very recent one. It's in June 1st, just a few days ago. It's a Tesla Model 3 that just had a crash in Taiwan. And actually, it was just to illustrate that these autonomous driving issues, they are really actual issues today. So it's quite popular, but I think it's a questionable way to think ethics for engineering. So I will explain this, and I will tell you later how I think that we should consider ethics for engineering. So first of all, this dilemma is very popular. And maybe the example I'm going to give is a way that have made this dilemma more popular. It's the moral machine from MIT, where you have a website where you can apply this dilemma and choose between different situations. Like, for example, these pictures are taken from this moral machine. You have a car and it's going to crash, or it may kill people there. And you have to choose between these two situations. For example, in that case, there will be an accident resulting in the death of one woman doctor and one old man. And in the other case, if you steer your wheel, you will have an accident resulting in the death of one criminal, one homeless, and wounds for one dog and one cat. And this moral machine system proposes you to choose what you think is best. And you have many cases of this kind where you have to choose between two different situations that are very bad situations. Actually, it is popular because also people are thinking about how to design algorithms that take decisions. And we have already had discussions about this earlier this morning. And the question is also about moral assessment by humans. Well, personally, I think that this is not really a good way to pose a question. And I would like to consider this. Should you reply to this kind of question, or should you refuse to reply to this question? Because I would say, on which criteria human life would be better than another? Who is able to decide for this? And who would take the responsibility to implement such a criterion in an autonomous system? So I personally think that this that exercise of thought is just a shocking and monstrous exercise. And we should refuse to reply to this kind of questions. And I would like to make a parallel. I think it's like a moral supplies. If a tormentor asks to someone to choose the instrument of torture, this is a bit weird, but I just give this example to make you understand. If a tormentor asks to choose instrument of torture, it's better to refuse to reply, because if you reply to this, it's like a beginning of consent. So I think that we should refuse to reply to this kind of questions. It's shocking, it's monstrous, and it's not a good way to pose questions. And there is still an important question: is should we delegate decisions to autonomous systems? Because if we go forward in refusing this kind of discussions, we could say, okay, we should even refuse delegating decisions to autonomous systems in any cases. But I think this is also a too extreme position, because there are already existing and accepting systems to which we delegate decisions, like automatic airplane pilots, automatic subways, pacemakers. Pacemakers are accepted by everyone, and in some way you delegate to these systems the decisions to impulse the rhythm to the heart. And automatic airplane pilots, you delegate when they are on, you delegate to these systems decisions regarding the flight and regarding human life that you need to preserve, of course. So actually, I think that the trolley dilemma is maybe fun, but it's simplistic, it's just theoretical, and it's an ill-posed problem. So if this is so, I think you can ask, so what do you propose? And I think we need to think about ethics for autonomous systems in a different way. I think that, so I would speak more about autonomous cars or autonomous systems, maybe in a more general way. But autonomous cars is maybe what we have in mind as it's quite popular. I think we should think the autonomous system differently at a higher level, as a global system interacting with its environment. So we have to consider vehicles, in the case of autonomous cars, vehicles, infrastructures, drivers, pedestrians, and other users. Also the natural environment, including animals. And we should consider the value and responsibility, value and values, also general values. What is the added value for society of such autonomous systems? Is it comfort? Is it security? Is it congestion, which is a very big issue of cars in cities? Is it pollution, which is also a very big issue regarding the environment? And we should consider the responsibilities of actors, system designer, manufacturer, user, infrastructure manager, regulators. And if we look at some references of moral philosophy, I would like to give you two references. I like to mention the work of Emmanuel. So actually there are two French philosophers. I'm not restricted to French philosophers, but these are two French ones. Emmanuel Levinas in Éthique et Infinie in 1982, who speaks about the responsibility for others and the way to consider the face of others, visage d'autrui in French. So it's very important. He says you need always to consider others and other human beings in your moral interactions. And Paul Ricoeur, in what is called the Little Ethics, in a book published in 1990, Soi-même comme un autre, he considers three very important elements, which is something regarding the person itself, so self-esteem, others, caring for others, and also general institutions. So this should be done within fair institutions. And these two thinkers help us to consider handling tensions, considering others in various aspects regarding ethics, moral, because they may be considered different, ethics and moral, law with norms, applied ethics. And it's what we want, it's applied ethics in this case. And so, and I will finish by this slide. From a designer or developer point of view, how should we consider ethics for autonomous systems? I think we should think global. So developers or designers should not consider themselves as isolated technical designer or developers. And everyone who is a tech person has to consider that his awesome invention may have impact on people or things that they have not imagined. And regarding care for others, I think that everyone should address the needs, consideration, ways of thinking, values of other possible actors, including simple, I would say simple quote, actors like your grandma and your young nephew. They should understand what you are doing. They should consider, and you should consider what they think and what their feedback about what you are doing. It's also why I think also the researcher responsibility is important to explain and popularize findings so that everyone can understand what researchers are doing. And I think it's also very important to consider dialogue with users and society. It's a way to implement this care for others, this way to handle the tensions between ethics, law, norms, and different ways of considering things. Okay, thank you for your attention.
Thank you so much.
Thank you.
Thank you. So the question time is after your talk. Okay, so Tatsu, are you ready?
Yes, I'm ready.
Okay.
So I try to clear my slides.
Yeah, thank you for waiting.
It's okay.
Yeah.
Could you see my slides?
Yes.
Okay.
Yeah.
So my talk is Rule of Law after Humanism, and I will give you the reason why I choose these slides and the stats slides as my presentation later during my presentation. And before starting my presentation, I'd like to introduce myself briefly. So I'm Associate Professor of Law at Kyoto University and visiting researcher at Riken AIB. And I'm also a principal investigator of Japanese side, JST UKRA project, Wearable Law in the Age of AI, with Phil, who gave excellent talk already today. And I'm a member of the drafting committee of governance innovation, redesigning law and architecture in the age of society 5.0, MAT in Japan. So I'm roughly a law and STS guy from the viewpoint of sanctioning system. Okay, I'll start the presentation. So rule of law is one of the most important concepts of current legal and political system. Contrasted with the concept of rule of man, the concept denotes the reasonable and consistent exercise of power, namely exercise of power in accordance with law. To make power reasonable and consistent, especially from the Enlightenment era, law has been grounded on the human nature described by the philosophy. For example, in criminal law theory, a man should be punished only when the undesirable result or conduct is brought about by his free will, because free will, which allows a man to behave independently of his external circumstances, is assumed as the condition of reasonable man. The idea that the essentialized human is the fundamental constructive unit of society is often called humanism. In a sense, the concept is built on the human nature. The rule of law is the idea of humanism, I think. What I'd like to demonstrate in this talk is that this humanistic rule of law now faces two major interconnected challenges, and it is necessary to invent new concepts or ways of thinking about law to update the concept of a rule of law. The first challenge comes from the emerging shift of pivot of the power and the rapid development of AI, robotics, and emerging new technologies. If we manage to govern power which will influence our existence, we should focus more on non-human objects manufactured by private companies and enlarge our scope of rule of law. The second challenge comes from the tremblement of the concept of human. As brilliant philosophers and anthropologists, including Peter Paul, revealed that we don't belong to a single monolithic species, so-called human. Rather, we are hybrids of human and non-human, and there are many modes of connecting human and non-human. Therefore, we have many modes of existence and live in multi-species society. In fact, our character of hybridity influences our behavior, as excellent cognitive scientists like Dylan and Phil demonstrate. Machine interface intervenes our consciousness and caution when we interact with it, for example. But the concepts and dogmas like free will employed in the rule of law are very humanistic. Therefore, serious gap between humanistic legal concepts and multi-species society should be fulfilled. Recent trial involved with auto-driving system accident may illustrate this necessity. Turning to the first point, it is important to understand the recent trends of argument about governance system. Modern state theory that has tried to simplify the power relationship between state and people assumes that states should exercise power in accordance with law in order to avoid the infringement of people's rights or legal goods. But philosophers after the mid-20th century have repeated that this figure of power misses to capture many power relationships among the society. They were correct, because it is now obvious that the power relationship that influences us now mainly works among the multiple actors in multiple rights, thanks to the development of technologies. For example, everyone knows that a censorship does not occur only between state power and people, but between platform enterprises and people. The design and program of autonomous speaker directly affects our well-beings because the rates of miscomprehension of AI or scope of audit directly concerns with human causalities. Yet it is very difficult for state to set the concrete standards or rules to govern these technologies due to informational gap and liquidity of the cutting-edge technologies. Faced with these challenges, for example, Japanese government starts to launch the new strategy for restructuring governance system, described in the white paper Governance Innovation issued by the METI recently. That is a kind of cooperation model between government and private sector to achieve the policy goal. I briefly map its features as following. First, the government set the policy goal with private sector and designed the incentive structure with effective sanction and immunity scheme to make private sector accountable. Second, private sector itself sets the concrete standards and rules with the account and monitors its compliance by itself. Third, if something happens with its product or service, private sector tries to fulfill its accountability and cooperate with the government agency to investigate the cause of accident through providing the relevant information. And if it succeeds, it can continue its activity. Fourth, if it fails, there are two options for them. The one is to give up all. In this case, private sector and its product will kill the market. The another is pursue the second chance with enhanced accountability. If they want to stay in the market, they should plan to improve its product and its governance structure if necessary. The government will review the proposal with experts, and if approved, the private sector will continue its activity. Fifth, the government can store the relevant information from the involved enterprises, and if necessary, it shares it with the whole industry to update their goals and inner standards and rules. Sixth, to compensate the victims, sustainable civil liability and insurance regime is to be built. As a member of a committee that issued the white paper, I hope this system will work well. But what I want to demonstrate now is this is completely new for modern legal system that tries to simplify power relationship between state and people, and to describe all the necessary conduct rules of people mostly in advance. Rather, in this new framework, we have to probe power relationship among people. More precisely, powers work among human and non-human, because many non-human play critical roles in emerging society, as autonomous driving system illustrates. Therefore, if we still want to control power, we should enlarge the scope of law to govern hybrids. Then the second point jumps into the picture. We live in multi-species society where hybrids of human and non-human exist. To understand this, please look at the illuminating square in front of you. A computer is a typical hybrid in a sense. No metals can be themselves process the information you required without human effort. Human effort to combine many kinds of materials from the world allows it to be a computer. And no human can by herself process the information without supports from this object. In a way, you benefit from it now. Of course, there is a matter of degree. When I run on the field, although I'm still influenced by the gravity of the Earth, it seems that human himself runs. Or when I'm suggested a book based on my preference by AI agent and start to design it, some may say AI controls me. Anyway, at least it is obvious that we live as not a single species called human, but plural species made from multiple human and non-human. Therefore, I call our society as multiple species society. The reason I start my presentation with a picture of agility is following. That is, the concept of a dog and human appears in the long interpenetrated relationship between dog and human. We now start to appear as noble species in relation to intelligent machines. Given this, we should not simply assume that there is a priori subject and object, where subject can control object through his free will perfectly. As Peter Pearl observed, our intentionality is always composited, reciprocal, or joint due to our hybridity. However, humanistic rule-over doctrines cannot comprehend this situation well, and gradually cause serious problems. To illustrate this, I will pick up the trials involved with Tesla's car accident. This accident led to 2 trials on each side of the Pacific. The criminal one was held on the west side, and the civil one was just launched on the east side. Although there are 2 different types of trial in different legal systems, we can find an almost identical discourses there. The first appears in the reason for conviction of the driver on the west side. That is, even if Tesla's system has some defects, the driver can avoid the accident if he implemented the obligation to pay his attention to his front. According to the press, the driver was drowsy at the accident. The second appears in the Tesla's defense at civil litigation. That is, there should have been a responsible driver behind the system. Therefore, Tesla should be released from liability. These 2 discourses share the common assumption that object does not influence human, because it is just object. In other words, human should control the object through his free will, because it can be exercised independently of surrounding circumstances, the very axiom of humanism. Some legal scholars may insist that norms and facts should be strictly divided, and even if some machines may affect actual human subjectivity, the humanistic norm should be kept as it is. If I have enough time, I'd like to revisit these kinds of arguments based on pragmatism and its forwards, But at least it is obvious that if we let this kind of gaps between legal norms and scientific facts, we lose effective measures to intervene the interaction between human and non-human. Given the first point that rule of law gradually loses controls over the power relationship, laissez-faire ultimately might lead us to a nightmare where global market will form our mode of existence without harness. We do need novel and nuanced norms and legal concepts to tackle. But how? Well, that is a problem. Norms are concerned with modality of should. Therefore, they require moral theory on what the novel norms will be built. But usually, moral theories firmly tie themselves to humanism. Given this, Peter Paul's work has many suggestions to find our way. He argued that it is important to look to Foucault's virtue ethics and moralize the designing process to control the power. I agree with these points. Foucault's virtue theory, for example, allows us to evaluate the tendency or character of the hybrids without a reduction to the evaluation of human intent. And it is necessary to look to concrete designing process that influences the character of the hybrids. With this moral theory as a criminal law scholar, I propose that we should have more feasible and nuanced distributive standards of sanction in the emerging society. And with the virtue theory, the question what we want to be is a critical to steer ourselves among uncertain and disruptive relationships. To be what we want to be will require every participant to this relationship to be accountable. Sanctions should be imposed on an unaccountable participant in this region to achieve the goal. But to do so, we have to know who fulfills his accountability and who does not. To know this, we have to know what happens among human and non-human at first. I think many scientific disciplines help us to perform these difficult tasks. For example, anthropology of hybrids like multi-species studies is very informative to probe what actually works among interactions. Cognitive and neuroscientific approach to human-machine interfaces studies is indispensable to comprehend the character and tendency of hybrids. Robotics engineering should be a key to identify what is the accountable behavior of engineers in each situation. Simulations of human and non-human interaction through game theory may inform us what kind of interaction should be beneficial to our society as a whole. The scientific disciplines are decisive to identify who should be more accountable and what to be accountable means in the particular situation. But caution, the question what we want to be inevitably matters democracy, since no one knows the answer. Therefore, we also need an ample room for democratic reflection. In short, to distribute sanction to make actors accountable requires combination of many disciplines and democratic deliberation in experimental way. At this moment, law finally finds its proper place. Law should structure this whole experiment as productive as possible. I'd like to suggest the novel concept of governance for the emerging society, that is, rules of reasons with law. Rule of law requires law to play main role to form the society and situates court's interpretation of law at the center of the system to govern the power. I must say, this is not sustainable anymore. Of course, there should be a role of court and legislation, even in the new regime. Reviewing and reflecting democratic decisions in the courtroom must survive for our democracy. However, in the emerging regime I introduced today, state is just one player of power relationships among our society. It is still important player to govern power relationship among people. But to do so, as I mapped about sanction system, state must try to combine many reasons with the support from many actors and disciplines. The power is now governed by many reasons outside of law. Therefore, law should be a catalyst, an interpreter, and an intermediate to combine many reasons. Through this indispensable work, law can continue to connect every actor among the society, as an anthropologist once observed. From rule of law to rule of reasons with laws. This is my preliminary conclusion today. I'd like to end my presentation with a picture of Japanese traditional poem collection, where our ancestors struggled to figure out the creative relationship between human and non-human. Thank you for your attention.
Okay, thank you, Tats. It's a very new aspect from the law legal system side. Okay, thank you. So the final talk is going to be given by Dylan. Dylan, are you ready? Okay, good. Could you start?
Sorry, unmute. Okay, can you hear me now?
Yeah, of course.
Good. Did you hear any of that?
Yeah, I can hear you, right?
Okay, good. I'm a colleague of Phil Morgan, who spoke earlier on, and I'm going to talk this morning about autonomy, its legal and psychological perspectives. This paper emerges from my involvement in a very interesting project in which Minoru and Tatsu are participants, namely the project called The Rule of Law in the Age of AI, which is a project jointly funded by the United Kingdom's ESRC and Japan's JST. We've just begun this work, and it's proved to be very interesting insofar that it's a interdisciplinary project. And I think what this morning's sessions have done is to illustrate the need for the convergence of engineering, law, anthropology, psychology, and of course I forgot to put there philosophy. Of course, the danger with that is that we will mix up several universes of discourse. And I think this makes this area very, very difficult to find a way through. So I come from an experimental psychology background with an interest in human factors. And what I'm interested in doing is pursuing work using our driving simulator in Cardiff, which is part of the Centre for Artificial Intelligence, Robotics and Human Machine Systems, which is EU funded, even though the UK is allegedly leaving the EU. It will be funding us beyond that period. So this morning, I reckon there'd be two disadvantages of coming last. One is that others will have covered the area, and that others will have covered the area more competently than I can. I'm thinking in particular Raja's excellent presentation, which does overlap a lot with what I'm saying. I've taken a more kind of simplistic approach than most people and addressed the question of whether robots are sui generis. That is, are they a genus of their own? Do they have properties peculiar only to robots that sets them apart from other kinds of entities? What that would imply, of course, is that they have to have a distinct and separate legal system that would require different constraints to other kinds of systems, including other kinds of computer systems. So we can ask ourselves, what are the key characteristics that make robots distinct? And that's where I'm going to center my talk on today. And I've taken an analysis by Ryan Callow, a well-cited legal and a scholarly paper by Ryan in 2015, where he makes the case that robots and autonomous systems are distinct, and that they do so on the basis that robots act, whereas computers, which are themselves constrained by their own set of laws, whereas computers inform. So Callow makes this tripartite distinction between the feature of agency within a robot that isn't just purely an object, it enacts. And therefore, there are three features that he identified of this agency, one being embodiment, the other being emergence, and the other being social valence. And he found in each of these categories that there was sufficient evidence or logical argument, more often than not, to suggest that a robot was indeed distinct. I take the contrary view. And what I'm going to do is talk about each of these. First, I'm going to talk about embodiment. And part of the arguments that Carlo brought forward was that robots involve physical action, whereas computers do not. They offer information. And indeed, law in the US at least is such that they have no liability for error that's produced by a computer, which makes them distinct in some ways. But he made the point quite cogently, really, that robots act on the world and they can damage the world in various ways, bring about liability by having material or personal damage in the world, and that's what makes them distinct. And this kind of reflects a boundary that is pretty universal, although not completely universal, fortunately, between thought and action. And we often think that thought is quite a different ontological category to action. That's upheld by a lot of people within the domain of psychology. But I, among others, take the view that actually thought and action are less distinct than we have believed for a while. And I believe that that thought is the embodiment of action through emulation systems in the brain and so on, so that the act of thinking is the act of is producing a speech act which is not made public, and that speech act is defined using motoric code and is subject to the kind of dynamic systems that we see in speech that's made overt rather than covert. So my critique of these ideas about embodiment are based on a number of points of view. One is that it makes the argument based on setting boundaries of where a computer ends and the world begins, and that the classification of machines as computers is far too conservative. We could think back to, well, I can think back anyway, to the 1960s, where we knew exactly what a computer was, and that it represented a box with a video on it and a keyboard. And clearly that the edges of that distinction have been eroded by time. And so also is the separation of computers that produce data and output from actions. A simple example is the autopilot. Clearly, the autopilot is a computer at some level, but those actions are embodied in the actions of the aircraft. And we wouldn't make a distinction here between it being a robot and simply a computer and being distinct in some kind of way. So we can ask the question, is that autopilot a robot or a computer? The other theme that I find running through all the reading I've done is that the boundaries between where individuals end and the world begins are very often sharply made. And one of the lessons of psychology, and particular human factors psychology when it relates to things like accidents, is that we've got to take a systems-based approach. That is, that the connectedness of the human to the physical world is a dynamic and reciprocal process. Not based on different demarcated domains of activity. So the fact that robots and some autonomous systems are embodied doesn't actually make them distinct, in my view. So the other argument that Callum makes is the one related to emergence. And he takes the view that not all human behavior is programmed. Very often it's iterative behavior, but iteratively generated algorithms towards semi-arbitrary goals. So what we expect is from a robot more emergence. And the question is, of course, that in this emergent behavior, it is not entirely anticipated by the program or the algorithms that generated the behavior. And the question then does arise, who owns that emergent behavior? And although this idea of emergent behavior is an interesting one, of course, what we often find, and I think we tend to forget this, is the emergence of error. And that is that when novel behavior arises, is it an error of algorithmic programming, or is it actually creative invention? So is the robot acting in ways that weren't originally anticipated, and one actions that are novel? Is that an error, or is it creative invention? And of course, it's becoming increasingly difficult to know which is the case. We have had blossomed a whole new area of investigation called XAI, explaining artificial intelligence, where we Phil Morgan and I have undertaken some work with Airbus on this, where we are confronted with the difficulty of describing how networks, deep learning in computer networks and in robotic networks, how they work. What account can we give of the way that these systems behave? And of course, there is a converging element in emerging cyber law, and there are different interpretations of this. In EU law, for example, the right to an explanation. Never mind the right to an explanation, do we have the capacity to give an explanation of deep learning activity and so on and so forth? So the key point I'm trying to make here is that the emergent behavior, which is seen as by some as an advantage, has some, I have some deep misgivings about, insofar as the accountability of the understanding of the system can account for this behavior and any consequences of any legal outcome. The last point he makes is that robots have social valence, and several people have referred to this in very eloquent ways this morning, that robots evoke social responses in people, and that people are hardwired to react, making them putting them sharply into the category of being people-like, not too-like. And while this is a very strong feature of robots, there are some issues here about the extent to which it is a universal outcome, insofar as most studies have looked at the social valence produced by robots over the short term. So one of the arguments is that actually what we feel in terms of social valence is very short term. As robots become more ubiquitous, they will perhaps go back to being more tool-like than people-like. And of course, within our cultures now, there is a tendency to anthropomorphize nearly everything. I'm not sure what the position is elsewhere, but in Britain, we do spend a lot of time watching television where we anthropomorphize, usually as bourgeois entities, animals in the animal kingdom. And so that this argument may not be a strong one, given that culturally we are more inclined now to be more anthropomorphic in the way we see the world more generally, not just for robots, but for other animal entities who don't share our level of consciousness, and particularly the articulation of language. There are signs that the more anthropomorphic the robot, the more willing we are to share the blame or success. One wonders whether, when more long-term studies are undertaken, whether we will find this social valence to be a basis of robots being a special entity. So I've covered most of what's on this slide. I think I was very taken by Raja's illustration of the sow earlier on, and I want to make that the point here that the social valence that we attribute to robots make them no more distinct, or perhaps even less distinct than pets. And of course, our friendship with pets fades in direct proportion to their unreliability or trainability. So there's a lot of work to do in terms of establishing how much social valence is a function of the novelty of robots, and how much in the long term we will regard them as artifacts in the same way as we regard others. So you will have got the feeling now that I don't think the case has been made that that they are sui generis, that the arguments about embodiment rely on an artificial segmentation of systems and a demarcation of systems. Language, of course, naturally promotes the idea that the world is made up of discrete entities, but we do know, not just for computers, but that there is the continuum of difference rather than discrete entities. The emergence fails to distinguish delinquent systems from emergent creativity. And I think this is going to be one of the great challenges in having allegedly autonomous systems, and the extent to which we can scrutinize the way they work and attribute the responsibility for outcomes that are not very favorable to their agency or their creators' agency. I believe that social valence here, I mean, this is an empirical issue, arguably, that novelty tends to foreground anthropomorphism. And I think that maybe a study worth undertaking systematically, or to take a longitudinal view as robots become more ubiquitous. Thank you very much indeed for your attention.
Thank you, thank you, Duran. So actually, oh well, so due to my bad organizations, we have only 10 minutes until the end of the workshop. So first of all, Duran, please just wait. I'd like to show the some, Duran, could you release? Oh, okay.
Okay,
yeah,
I'll just, sure, yeah, okay, good.
So now you can see the question to the Peter Paul and also, yeah, Peter Paul and some dinner discussion. And also François. Okay, so Peter Paul, you have the two questions.
Yes, thank you very much. So two questions from Megan. One is it about intentionality or user analysis responses, the flash versus a flash? And is it about, well, doesn't the figure 8 system reduce human interaction with the environment? interesting questions. So I think user analysis responses would not entirely cover what I would mean by intentionality. That's maybe also quite a phenomenological concept. So for me, intentionality is describing the ways in which humans are directed at their environment. And of course, analyzing user responses, or well, analyzing how users deal with robotic systems can be a way to understand human intentionalities towards robots. But there's more than you can find out along that way. So I think if you want to study intentionality, typically I would also go to ethnographic methods. And we've also done actually a lot of work that tries to get in touch with the interpretive relations that people develop in their intentional relations with the world around them. So user analysis responses could maybe give an idea of mediated intentionality as well, of seeing how robotic systems well, become part of the interactions that users have, not only with the robots, but also via the robots with their environment. And about the figure 8 system, the landscape, well, maybe also that it is not really about interactions with the environment. This is really about interpretation. So it tries to analyze how robotic systems help us interpret the world, and also help us to give, well, help to give us a different relation to the world. So it's by interpreting a technology that from that interpretation we have of the technology can help us to make sense of the world around us. And in that new context that our new understanding of the world then gives, the technology gets a different role and giving us a specific role in that world. So of course, there's also an interaction between humans and the environment, which is really important to study. But the foundation for that interaction, I would say, is always kind of an understanding of that environment, an understanding of the robotic systems that give us a relation with that environment.
Thank you. So the next one, the François, could you answer to these questions?
Yes.
Yeah.
The question, so from Fabio, who asked, how would you shape the decision algorithm for an autonomous car? Assuming it is an infrequent limit case, how should the decision emerge in that case? Well, I think we should not consider it in the way the trolley dilemma poses a problem, which I think is the wrong way. We should consider it at a higher level. In that case, what is assumed is it's about security. And the question is that do autonomous systems may achieve a higher security? And I think that for social acceptability, this will be what will make autonomous cars acceptable, is that as the overall systems, the security would be higher. And actually, I don't know precisely how to reply to this question, but if we put it this way, it's a known question in other industries, like in trains and railway industry, also for airplanes. It's how to deal with risk and to design systems that are safer. And there are lots of ways, design methods to design systems that are safer. In the question regarding the fact that it's an infrequent limit case, for me, the point is not that it's infrequent. The point is that it's ill-posed, because we have to address infrequent limit cases, but to put it really for a specific objective, which would be security. And last point is that, in my opinion, for the trolley dilemma, we assume behind that the question is about security. But for autonomous cars, as I was saying, I think that the question should not be also only security, but also comfort, congestion, pollution. I think that it should be posed as a global society problem.
Yeah, the Flavia also says the comment that that case is a trolley dilemma, something. Okay. Anyway, anyhow, thank you. Yeah. So we have one more, general discussion. So Dylan, could you handle this one? So okay, I just read that. According to the British political, the first part, the Thomas Hobbes, the state, the government is artificial personality, which is connected to determining the legal ethics for the students. Without such artificial personality in the state of the nature, people have only cardinal virtue, false and flawed. This may be the relevant to the issue here. So this is a very general discussion about some artificial personality. So Dylan, could you handle this one?
Well, far be it from me to comment on somebody as august as Thomas Hobbes, really. I mean, I think this is the interaction of what we know as psychologists or anthropologists with what the state will wish to do and what the legal system will wish to do. And I think this is where we come across several universes of discourse coming together. I'm on the verge of saying I'm not qualified to answer this question. I mean, I don't think it does have a very straightforward answer, actually. What we need is a political scientist now.
Mm-hmm. Okay,
I'm not sure if I would qualify as a political scientist. Not at all, actually. But I think the interesting thing of what Hobbes tried to articulate is that we need something external to be able to rely on. And maybe in that sense, that fantasy, maybe that there is something beyond us, is also something that you see in the debate about robotics, where we also sometimes try to make the argument that an algorithm can be more objective or more neutral than a human being, that a verdict by an AI system can be less biased than the verdict of a judge. But actually, I think in most of the cases, we find out that this is not the case. That of course, the algorithms are trained with data sets and that they are as biased as humans are, that we maybe also need to learn not to rely on something external to us only.
Okay, so is there any other comment? Yeah, please.
Or may I jump in this question? So I think I don't know what he would like to ask exactly, but if he is wondering what about is there any necessity to give a legal status to the AI or robotics to treat them in a legal sphere? For example, I mean to reach something in legal context, we need to give some legal status to them. That is his question. If that is his point, I think it is too far to give the legal personality to AI or robots, because without that, we can treat the robots or AIs in legal sphere. For example, if we treat when we treat animals as an object of protection by law, we don't give them as legal personality, give them legal personality, but we can protect them in a legal sphere. And so the legal personality and legal status is a different concept. And as Peter Paul said, this is too simplistic view. Maybe we may have the points of Archimedes or something like that to reach everything as the same in this kind of theory, I think.
Okay, so thank you for comments. So is there any comment? So actually,
I see yet another thing in this suggestion, because it sort of elicits to me something that we do in the work of meaningful human control, where basically, so part of it is finding a way to attribute agency, but mostly sort of responsibility, so control and responsibility, to the whole spread of agents, even at more abstract levels, such as, for instance, the state, the government, the regulations, the set of values structuring a certain society. So, so one of the problems or the suggestions here would be, how do we create the form of control that is meaningfully attributable to also these very sort of distal agents, such as, or abstract agents, such as the state. What is the role? What is the agency of the state and its regulations towards technology or the behavior of technology? So this is, in a way, another perspective that I read in this suggestion from Taiki.
Thank you for suggestions. Actually, now it's the end of the workshop, and we have discussed many issues, and also we realized that so new technology needs some sort of the new way to think about how to how the humans and the artificial systems could live together and think about some new values and a new concept, and also some sort of will change some legal system or not. Of course, they're very, very hard discussion, but at least as I know, our side, my side is just the engineer or designer side, to think about how the artificial system influence the society in the many aspects of something. So today we can we discuss the many issues, and I suppose this is only just the beginning. So from now on, we should continue this kind of discussion among the people of the many different disciplines and so on. Okay, so I'd like to close the workshop. If you like to say something more or something, it's okay. It's okay.
Thank you so much.
Okay,
Thanks.
Thank you so much for the everyone, and thank you for the audience. So still we have several comments. So after the workshop, we try to respond to these the questions, the comments. Anyhow, thank you for everyone. Thank you for. I'd like to
Thank
close.
you all. Thank you.
Thank you.
Thank you. Goodbye.
Thank you also, Minoru, for organizing. Bye-bye.
Bye-bye.
No.